Namaste. Thank you, Dr. Ramesh, for your introduction. Well, I am associated with this organization from more than 3 decades and various capacities. All of you are from Karnataka? Oh, someone from Maharashtra. I was wondering. Tamil Nadu, yeah. Because this talk, I don't know, some of you have already seen in some forum, I don't know, because this, I think, more than 100 times I have used the same slides. I cannot keep on doing new work. One day I should try to find new audience. Hope all are new. And all the videos that you are going to see are something that we have done in our lab. Not YouTube download it. And it is not a Google Gyan. There's something that we have done in the lab. More than 500 youngsters have contributed to this. For a period of more than a decade, they worked very hard because our lab supports a lot of interns. In fact, more than 100 per year, that is our turnover rate. We support so many interns. We encourage them to explore themselves the newer technologies. So it is their walk and my talk. Okay, so that's the thing. So we will go through some basics. What is this drone computing? We all use drones today. So I define this as the use of computers in drone driving and drone data deciphering. Generally, drone driving means, we have seen there is a pilot who is on ground with the transmitter. There is a receiver on the drone. You give the inputs and drone will get that output. It will behave as the pilot wants. But thanks to AI technologies, we can automate several such things. Without the pilot, it can fly. We will see some such things. Then, flying is not the only thing. The data that you get, what is the application? That is where today more opportunities exist. Flying the drone is no big fun. If you have visited our department with 3 floors, there is a quadrangle in between. Long back, about 15 years back in our lab, because our lab is one of the first academic lab in India to start activities of drones. It was actually inaugurated by none other than Ratan Tata. I don't know, I have to put those photographs. I will do it next time. At least let me make small changes in my PPT. Because from past 1 month, I have given this talk 20 times. There is so much of interest in drones. Anyway, then 15 years back when I used to fly, something used to take off. Then a lot of people used to assemble all around. All the 3 balconies were full. They were peeping. Students, faculty, what is happening? Now we have better flying machines. Nobody looks at it. Nobody cares. In fact, they complain. Why are you making sound? Do it sometime Saturdays, Sundays. Because people have got bored looking at these drones. But why I am saying this is just flying is no big fun. That is over. Those days are over. What is the application to which you can use? That is most important. There, the role of AI and other ideas, very, very important. I will try to show some of those things. Well, this is the overview of some of the drones that we have done in our lab. You can see from nano to, that is 300 mm span, all the way up to 4 meter span we have done, rotary, fixed wing, hybrid, more than 100 different vehicles we have designed, fabricated, flown, tested in our lab. And making these things is not very, very difficult, especially fixed wing. That's why I see a lot of youngsters, if you want to quickly make one of your vehicles, fixed wing is the best. And you can just use a form, simple form. I'll show you some of those things also, what you can do. Well, today the drone is one of the components in the popular IoT, Internet of Things. So drone has to be integrated into the IoT. And this is a network of drones flying. Very soon this is going to happen. It can be carrying some people, air taxis. It can be carrying medicine, organs, medical drones. It can be carrying some objects, logistic drones, multiple applications. It's all up to your imagination. First one we will cover is this. These drones, how do you drive these drones? Generally I said that the pilot you will drive. Otherwise there is an autopilot. You can go to Google Maps, select where all you want to go, and there is a path planning software. Give this there, burn onto your firmware, launch it, it will go, do that. That also we have done. But this is something unique. What is this? This is thought-driven drone, brain-computer interface. I'll sit and think it should go up, the drone should go up. I simply think it should come down, it will come down. I think it should go to right, it will go to right. I think it should go to left, it will go to left. Only thinking, not even gesturing, no words, nothing. Is it possible? It is possible. How? We use what is called as EEG headset, electroencephalograph headset. Whenever, of course, people always keep thinking, even as I am talking, you are thinking something, because mind is such a thing that it cannot be quiet. So when some thoughts are going on, there are a lot of electrical activities going on in the brain. Those electrical activities also reach your scalp, and from there you can capture by using these electrodes, and you can get to know the wave patterns. How exactly it is connected to thoughts, that's a totally different story, because this is how the waves look. On the bottom you can see, it is so very difficult to understand. But yet, if you can focus your mind a bit, and let us say you think about the direction left, think, that's all, nothing else, then a particular wave will have a feature. If you can extract that, then you can convert it into drone understandable command and send it to drone, make it to move left. Similarly, right, up and down is possible. We have used 14 channel epoch headset. The challenge here is signal processing. Okay, this is our quadrangle where we have tested, and I am sitting there and thinking. You can see the drone moves. You can generate about 4 commands distinctly and drive. You can see a lot of YouTube videos on my lab's website. So in fact, we did publish about this, that the news channels were very much thrilled, and lot of news channels covered this. Next time I think we should include one of that at least. I forgot. We are scientists, no, we don't know how to do publicity tricks. Next time I will do. Now I am getting these ideas, I will do it. We have a lot of youngsters. Neeraj himself is there. He is in our lab, so you have given him advice that you should help your master to get more publicity. So good. So now imagine a situation like this, Bangalore. Most of us know the traffic. Ambulance also gets stuck in the traffic. And with all its huge siren, no clue for the policeman what is happening because so much of noise, so much of traffic ahead. Suppose there is a drone sitting on top of the ambulance and the driver activates the drone will go to the signal, alert the police, and police will make the traffic flow. Then the drone starts moving, the ambulance starts moving, drone has to come and perch on the moving ambulance. So now that's what we wanted. So we made our own ground vehicle, small one. Now you can see the drone will take off and then the UGV will start moving, then the ground vehicle will move, then the drone will adjust itself. On top you can see we have put some RQ codes. So there is a down-looking camera, so you can write a small vision-based algorithm so that it will perch at the center. This is possible. Then a situation like this, where you have a lot of trees, for example, tea plantation, lot of trees are there, and for either spraying something, or to study the tea leaves structure, you want to send a drone in between. Very difficult. Even for a pilot to carefully understand, to maneuver through the trees is not possible. And it is also possible that GPS is not available under tree cover. So only option is vision-based algorithms. So we tried a couple of them. Number one, based on linear regression. Don't worry what it is. It is on texture-based learning algorithm. That's what we tried. So this each window picture is captured. You divide the window into a stripe of about 22 windows. Then we extract some features, and then from image to image we keep training. We use a linear regression learning. If you are interested, we have published, you can always download and get to know. So this is the result. So this is at IISc, how it moves through the woods. Left side you can see, right side is the computation. How computation is taking place. So it just moves. And there is only one monocular camera. And there is an Android computing platform which will compute real time. Nobody is controlling. It is going autonomous. Once the point A and point B are specified, it will simply execute. But there is some problem here when you have a horizontal branch. Suppose a tree has a horizontal branch. Not very likely, very rare. Then this has little issues. Therefore, we looked at what is called as optical flow algorithm. So there we have used reinforcement learning. Left side figure shows what is optical flow. When from frame to frame, we look at how the pixels are changing and then compute the optical flow. So we make certain assumptions, and the brightness consistency should be there, and it should be small motion. So your frames per second should be good if you want to do that. So So we did that, and this is the result. The optical flow algorithm. It keeps moving. This is our IISc campus. Those who have seen, you can see that we have a lot of trees still existing, although many buildings are coming up. Some trees still remain. Then imagine a situation like this. Suppose the army convoy goes in search of some XYZ, and you don't know how the path is going and what is there ahead in the path. Not known. If it is not known, then you have to explore. How do you explore? You don't know how it is going, what is happening. Suppose we use some learning algorithm. There is a camera. And suppose if you have to go, how do you go? You can see the edges of the road and we simply go. It's automatically happening, we don't realize. Our brain says, okay, edges. Similarly, can you detect the edges by the camera and it should center to the edge and simply go? Is that possible? That is path following algorithm. Here, what we do is we use a novel concept on deep learning called as imitation learning. What is imitation learning? First, what we do is we ask the pilot to move the drone. Depending upon the curvatures, we ask the pilot to give the inputs. We see how the drone maneuvers. We take the inputs of the pilot and the response of the vehicle. Then we train the network. Then we replace the pilot. That is called imitation learning. So our algorithm will replace the pilot. So we can train it in multiple ways. Not necessarily you have to always drive a drone. Even you can use a car game. In computers you have car games. Those key strikes, inputs, and how do you maneuver. The same thing can also be used. We used all these things, and you see, this is also IISc road, and the drone nobody is controlling. It is moving at a speed of about 40 km per hour. It centers itself to the road and keeps moving. And we have also accommodated junction disambiguation, which means if you get two roads, then which one to take, you can program that also intelligently. So all that is possible with this. The possibilities are multiple. Then we look at some of these applications we have done in agriculture. We would love to call it as LARS, LARS. LARS means low altitude remote sensing, as opposed to satellite remote sensing, which is from high altitude. That's all the meaning. So we have done a couple of applications on this, and this is one work we did on tomato. In India, the vegetables that even shake the government is top. Tomatoes, onions, potatoes. These three. Okay. Recently it happened with tomatoes. 300 rupees per kg. Okay. And it can come to 30 paisa per kg. And in Kolar and Tumkur, they will throw it on the road because farmers cannot even afford transport. We wanted to understand this problem, and the reason is because supply and demand is not understood. Everybody grows tomato, there is excess, rate goes down. Nobody grows, there is huge demand, rate goes up. Suppose you use a drone, scan the whole area where tomatoes are richly grown, and estimate, because it's a 3-month crop, estimate in a couple of months what is the likely production, so that the other farmers can take a cue and decide, okay, let me delay, let me do something else, whatever, some other vegetables, etc. So first right top is the UAV image, one clip we have taken. Then we did this pixel-based classification algorithm. Initial work we did what is called as self-organizing maps in neural networks. Then the last picture C, you can see we have whatever we predicted is overlaid on the original image, and you see they perfectly match. So we will be able to classify properly. But the disadvantage with this method is still you will have to, if you want to count the number of tomatoes, very difficult. But now we apply deep learning networks where you can detect tomato as an object. You can pick up. That we have done. That involves a lot of creation of your image data sets. We have done, we have created our own image data set for tomatoes. We have done, and the result is here. This is what it is. So this is the same UAV image taken from UAV, and the boxes are put by our algorithm. Number of boxes is equal to number of tomatoes. So you will immediately get how many tomatoes are there. Then the size of the box is proportional to size of the tomato. Then we get the color information RGB. How do you buy tomatoes? You may not buy. Your mother or wife or those who have grown up. When they buy, what do they see? Size and color. So you can grade the tomato. Everything is possible through this. And then you can put it on a cloud computing platform. Automatically it can happen. And then any purchaser can simply look at the database of the cloud. You can put your own price tag. They can talk to the farmer directly. Get it done. That's it. We published this. Is it not a good idea? Thank you so much. In fact, Deccan Herald published, once we did that, Deccan Herald published, and this became a big news. And somebody, the principal secretary in government of Karnataka, called me. He said, "That is a fantastic work, why don't you give me a presentation?" Went to his office at Vidhan Sosa, and 2 hours presentation we did. I don't want to name. We did. After hearing to our presentation, that gentleman remarked, "Where were you all these days? You have solved one of our problems. You let us know how much money you want." We were thrilled. We thought our work has yielded some good result. We are going to do something for the people of Karnataka. That was the first and last meeting. Okay, that's why I went to the next topic. ಆಮೇಲೆ ಮಾತಾಡಿಸ್ಲಿಲ್ಲ ಆ ಸರ್ಕಾರನೂ ಹೋಯಿತು ಅವರು ಎನಿವೇ these things happen. Of course, these things, for those of you who are working in some connection with government, you all understand my pain. But anyway, that's what it is. Now next application is, suppose there is a forest. You want to know what is the kind of species that are there. Can you do that? Yes, in IIT we flew the drone, then we capture the image, then we use some classification algorithm. We have used more than 10 classification algorithms, neural network, bio-inspired techniques. You can see my publications, I don't give all those results, but it is possible. So in any forest you can do, you can know what are the type of species that are there, so that it will help you in computing carbon footprint, biomass estimation, etc. Then mango is another commercial crop. Mango, what happens if you take a mango plantation, there are several mango trees. Each will have its own canopy, which means that width of the tree plus height, they can be different. Now you take one mango tree, take a picture, and then compute the number of mangoes. Now you know the canopy of that tree. Like that you keep on repeating, and then once you understand this relationship between the canopy size and number of mangoes, now you find out how many such canopies are there, so that you can get the yield very quickly. That's what we do. I don't know if someone has used, but it is possible. See, what we do is we do the work and publish. Anybody can take that idea and might have used, but it is quite possible. Maybe. No, in one of the committees I was there, but I don't know what you are referring. Because the committee in which I was there, they simply spent the money and nothing came out. I was there in that, I was a part of that committee. We told them that it won't work. Please don't give it to some XYZ. Taking simply photographs is no good. ಅಂದ್ಬಿಟ್ಟು ಮೂರು ಪ್ರಾಜೆಕ್ಟು 3 different projects worth about 2.8 crores. Okay, so we discussed at length, we told don't go for it. But the answer we got is something strange. Don't quote me anywhere. Oh, you are recording, yeah? You are recording. I should not go on recording. Okay. Doesn't matter. Anyway, everything good. Okay. Everybody is doing good work. Okay. So this is positive. Then Mango, don't worry about these algorithms and things like that. We use what is called as convolutional neural network. So this is essence of deep learning architecture. It has multiple layers because it can extract features, different features at various levels. So this is what it is. This is one thing I want to attract your attention because you can see, especially very simply to understand, in second row, first column, you see mango is being covered by a leaf. But still, the algorithm is able to pick up as mango. So that is the beauty of these algorithms. They understand things even when they are covered. Partially export is also good enough. You can do that. I just want to show that. Then this is the mango tree. Now you see the boxes around the mangoes. So number of boxes is equal to number of mangoes. Similarly, size, color, all information. One question people ask, what about mangoes that are hidden? If they are hidden, well, first answer, if they are hidden, you cannot pick up. But good answer, generally these mangoes are not hidden. The reason, sun. Only when they get exposed to sun, you get good mangoes. Some bad fellows will sit there, anyway it doesn't matter. So, mangoes, you will get immediately from the algorithm. That size, see, if 2 mangoes are like this, it will not detect as separate, but it will put this size. So from that you can compute, because yield we compute generally by weight, not just the number. So you will get the total yield. Oh, that you can do a 360 degree. Yeah. You can do. Very, very simple. 4 sides you take it. Then the whole plantation you can look at. You can extract the whatever is through segmentation, and then whole canopy you connect. Then this is the extensive mango network architecture. This is what we call as the deep learning architecture. And once you know the canopy and what is the per canopy number of mangoes, you can get the estimation. Then this is something I agree home, I think Neeraj will cover this, correct? Pomegranate you are covering, yeah? Good. That will save something for my throat. So same thing you are covering? Okay, so then I will drop this because let him cover about the pomegranate. Neeraj, my student, is leading one initiative on precision agriculture. So he will perhaps detail you more during his talk to follow my talk. Next we have done is one work on eye in the sky. You know, now drones are used for a variety of applications, including monitoring the mobs. For example, they were using recently Kumbh Mela, crores of people. So they fly hundreds of drones to watch out. All the video feeds will come to a control station. So they want to see if some unrest is happening somewhere. Some violence activity is breaking out somewhere. But whatever, right. So hundreds of videos, one person or even 10% cannot keep on seeing. Suppose you do image processing and you can identify the violence activity automatically. How do you define violence activity? Hitting, kicking, pulling, chain snatching, molesting. All that can be trained. You have to train. Now any such activity takes place, it should immediately flag. Lat-long location is known, then immediately say violence here. Then law enforcement authorities can take appropriate action. This is the idea with which we started this program, this project. One of my good students, Amarjot Singh, Dr. Amarjot Singh, and myself, we did this project. I should talk about how youngsters, how hard. Amarjot Singh, now he is PhD from Stanford, he has his own company. But when he was a student in Warangal, NIT, he used to come to do internship. Right from third semester, he used to come. He is from Amritsar. And of course, I had the good time of spending some time with their family there. He used, after the exam, he did not used to go to Amritsar. He used to come to IISc, to the lab. And he used to work so hard. Then one day he told me, sir, going to this dormitory, PG and coming back, I want to save that time. Then I asked him, do you want to sleep here? He said, yes, I got him a bed. And from then on, he used to come, work, sleep, get up, work, do that. Hard work. Today you can Google his name, Amarjot Singh. You will see where he is. I am just trying to inspire some of the youngsters who are here, how hard work you can do a lot of magic. So this is what it is. In general, any violence taking place, you should do. I tell you, this also gave us a lot of publicity. I will show you, I will talk about this later. So this is the algorithm generally. And first step is you have to detect human. Very important. You must know that you are addressing the human. Because if the drone is capturing some two dogs fighting, you should not flag it as violent. Unnecessary police and all those things will problem. So first is identification of the human. Second one is their pose estimation. So this is the very crux of the thing. How is this pose? What kind of action? Then the orientation, you should check how two people or three people, etc. are oriented. Then you have to classify. Any classification algorithm you can use, we have used support vector machine. Then you can say it's violent or not. And even when there are multiple violence activities, you can pick up. In a scene, suppose 2-3 groups are fighting, all that you can pick up and flash it. So this we published in one of the world's leading CVPR conference, the world leading vision-based conference. And it attracted the British Broadcast Corporation, BBC. And they interviewed us because of this algorithm.
Teaching kids to spot violent behaviour in crowds using AI. It's the talk to computer scientists who conducted that research. Dr. Onka is from the Indian Institute of Science and he joins us from Bangalore. And Amarjot Singh, who specialises in artificial intelligence at the University of Cambridge, is here. But I think you don't know the university is your own particular research. Dr. Oakland, if I can start with you. How does this work in terms of the algorithms? What exactly have you done?
Algorithms are based on machine learning, which actually learns from experience. These are all things which are
And I was going to say, who specializes
Anyway, this is available on Google, etc. You can see if you are interested. This jet I also use it for publicity. Okay. Right. Then we did one more algorithm, not directly related with drone, but an extension of this, called disguised face identification. Which means, suppose if you are covering yourself with a mask and goggle and hat, still you can be detected. Suppose if a girl wears a mush and beard, maybe covers his hat, etc., can be detected. This is called disguised face identification. And this also we published, and this also BBC feature. And this came in the front pages of various leading magazines. And you can see that. This is our lab. 14-point representation we use. You can see a girl wearing beard and mush. Still we can pick up. All done in our lab. We had to create a data set. That's the crux of the thing. Then we have done on flood victims, can you use this image processing, because you can fly a drone and identify who was struck where, how many people. This will be very useful for the rescue authorities. So we did, this is the algorithm overview. We use what is called a region-based convolutional neural network, which is a multi-layered architecture. And of course the YOLO, you all know that this algorithm. So this is the result. Even when they are caught in the water or rooftops, we can detect how many people are there. Even animals, cats you can detect. You can see the picture somewhere here in the second row. Then road extraction. You can extract the road using convolutional neural network, and you can find out the health of the road, whether there are any potholes, or whether the bitumen is laid properly or not, how much is covered, etc. That is possible. Then power line monitoring. Today, you know, these power grids, they run over the hill, etc. Very inaccessible areas. Even today, it is monitored by humans. And when you say it is monitored by humans, what do you understand? Nobody will go to inspect. They will simply sign that it is inspected. Because who will go climb up and down, see, very difficult. So, sometimes they started using helicopters, but it is very expensive. Even today it costs about 75,000 rupees per hour, helicopters. So we thought, if a drone can be designed, if it can identify the cables, you just leave it on top, it will simply track the cables, 15 kilometers, 20 kilometers. And you put a thermal camera, you have to only detect the hot spots where power leakage is taking place. That's all what it is. And then you can note those spots, their black line location. You can do good preventive maintenance. So we started on a 220-volt cable system itself, which is difficult to detect, but that itself we can detect. So high tension cables is all the more easily detectable. We did this is, I think, Bunsen 6 stage. And this is the overall algorithm a lot of things are involved here. Then you see the last figure, the cables we were able to detect. So online, we have demonstrated in real time. So now this can be used. So this is one of the important. This is for students. This is this aircraft made out of foam. You can assemble in less than 42 seconds, less than 1 kg. Simply, you can have a camera. You can assemble in 42 seconds. Simply throw it, you will fly. Come back with the images. Very easy. You can carry it on our backpack. That is our airship. Okay. Then this is something easy. Anybody can do. This will cost about 5,000 rupees, not more than that. And that is only for motor and propeller cost. Others is all foam. You can use a hardware cutter. Our students should try all these things. Then this is quite involved. See, this is very lightweight. 800 grams including motor propeller. See how it launches. Very lightweight. Even if it falls on somebody, no danger. Only 800 grams. So this is one of the things. Very strong. That's the thing. This is all composite, but this has a lot of truss. We use the filaments and do. So a lot of technology is involved in this. Then this, it can take off and move forward. Because today's world, you don't have good runway to go. So especially for agricultural purpose, something should take off vertically, move quickly forward, then land or descend vertically. So another version of that is the following, which you can see. This is also one thing we have made. This is quadcopter and a fixed wing. First it will go up like a quadcopter. Then there is another propeller, which is tractor, which will push it to move forward. So you can move up from wherever you want and move quickly because of the fixed wing. Then you can descend vertically. See, it will take up vertically, you can reach any height you want. Of course, design. Then you switch off those motors before and then you push it forward and switch off the 4 motors. So it will move like a fixed wing. So it is the advantage of both the rotary and fixed wing. Yeah, so that's what it is. Then this is something on radiation monitoring, because today, suppose something happens in nuclear power plants, it's very difficult for human to access. The only way we thought, okay, why don't we use EAVs? The radiation measuring equipment is called Geiger-Müller counter. It is quite complex, and there is one thin glass tube which is heart of the whole sensors. So mounting that is very difficult. Suppose if the UAV lands that, this will break, but gone. So you have to do a lot of mechanical design very well. So we did all that. Then we wanted to test it. How do you test radiation? You should have radiations coming from somewhere. But if you go to any lab, physics lab, they will give you cobalt, which emits radiation. It will emit radiation only to 1 feet. That's all. You cannot go up in the sky and test. Then we found that there is Chavara coast in Kerala, where natural radiation levels are about 12 times higher than Bengal. So our team went to Kerala, sea coast, to test the radiation monitoring equipment with our UAVs. Oh, sorry. This is what it is. Disasters have taken place all over the world. In Russia it has happened, UK, Japan, US. So one should be ready. So we started here at Indian Institute of Science. This is our department, top view. So went to Chowra Coast at Kerala, 12 times higher. So first we wanted to do a controlled experiment. We used our quadcopter because easy to control, beautiful sea coast. So this is the glass tube you see, that's the thing. That's the Giger-Muller tube. And a lot of the sensors, of course, this is the imported equipment. And we flew it at different altitudes, recorded, we wanted to plot and ensure that it is 12 times higher than in Bangalore, so that gives the first level confidence. Now you see the bottom line is Bangalore, IISc. The top line, yellow line, Kerala, 12 times higher. We were happy. Now we put it on fixed wing because large area we have to cover. Fixed wing, now this is called Bhangi launch because there you cannot crawl on the sand. So use the elastic tube and launch it. Of course, this is a lot of design parameters to slide properly. Now this is what is called a waypoint navigation. We sit in the lab and program where all it has to go, how it has to go. Then it will come and it is called belly landing. It has to do land, it has to glide and land without any impact. That is it. So then it gives the information like this, lat-long location and the counts per minute of the radiation. You can plot it. This is the onboard video from the UAV, how the ground looks. You see the sea and some of the earth. Then you can get a radiation heat map like this, where radiation level is what. Well, failures are bound to be there. So when our students were there in one of the flights, it went and they lost communication. This is after that they noticed that it lost communication. It just went into a spin and everywhere water. So they all thought it was gone into water. That night they did not even call me that evening. I could also not access their mobile numbers because they thought that it is gone. But I'll show you the onboard video. Kerala is known to be land of gods. God smiled on us. This is the onboard video, water, but what happened? It reached Kerala's famous tree, coconut. Nothing happened. A savior came there. He didn't know what it is. He didn't know that there is a camera also. But he could test the propellers. We do have a dog somewhere there. There it is. This person took it to his home on his cycle, and after 7 hours, 11 kilometers away, they could trace. Locals helped there. Police also helped. The WhatsApp was of great help then. So we got it back unscratched, nothing happened. These are the team that most of our interns who are in this project, they are all abroad now. Okay, so that is it. And this is something all composite vehicle we have done. I'll just show you. Gas turbine, jet engine, that's why that sound. is all composites. See how it takes off. Okay. So this is some of the, we were the first to fly a turbojet engine UAV in India. We are the first to fly. Anyway, on roads a lot of accidents take place. Can drones be used to save them? So some of work we have done, because there are 400 deaths on road every day in India. And 13 to 14% people die because initial attention is not paid. So can you use drones? Using drones you can, for example, using a video magnification, you can find out their heart rate, blood pressure, etc. That's something you can see. Then on seed drop, because afforestation is one of the most important things. Even in inaccessible areas, you can carry seeds and drop them using UAVs, and you can run the UAVs again and again after 3 months, 6 months. Then you will also know the impact on the local ecology. That's why we propose this. Myself and my colleague Professor K.P.J. Reddy, we were the first to do this in the world. You can Google and see. Later, a lot of people have done, but we were the first to do it. So this is the at Gauri-Bidanur we did. The whole main road was blocked to fly this. It can carry 10 kgs of seeds. It can carry 4 varieties of seeds. The pilot can see on the video and decide where to drop. Or wherever the officials say, now you drop, we drop there. There is the open and closed mechanism. So Karnataka government helped us. Then super resolution. The whole idea is, UAVs, you can take very fine resolution image, spatial resolution. But spectral resolution is very small. It cannot it cannot cover large area. Whereas satellite, spatial resolution is less, but it can cover huge area. Can you combine the two? That's the idea of super resolution. We use again deep learning architecture called GAN network, which is generative and adversarial network. I'll show you the example. You see, this is what it is. Left side is the satellite image, right side is the UAV image, middle is the combined. So, large area, reasonably good resolution you can get. So, if you want to do some agricultural survey and all those things, for example, for the Karnataka, if you have to do, you cannot keep on taking UAVs or drones to every forum and keep doing so many images. How do you do it? Not possible. So use the satellite to get the whole area, then use the drones in some representative points, combine the two so that you will quickly get the data. Then this is about mineralogy. We want to explore what kind of minerals are there using remote sensing. So this is one of my students' work. We have done that near the area of Jodhpur. Then even on the moon, we have done moon mineralogy, done by one of my students. It's quite complex, but this is the PhD work of Dr. Sukant Rai, my student. Well, artificial intelligence, drones today, they have a lot of things. Anybody can work on drones because it's not just aerospace, please remember. In fact, if you look at the drone startups, Majority of them are non-aerospace people. Electronics, electrical, computer science. It's all your idea that can take you there. Don't worry about this. Jai Bharat, Namaste. If you have any questions, you can ask. And about the drone violence activity detection, I think you asked the question. It came in the front page of Prajavani also. At that time, some people from police department approached. We had a good talk. I think so. Anyway, before I forget, Dr. Ramesh, next time when you do any workshop, when you want to print your banner or poster, ask me for a few images. I'll give you Indian images, don't put Chinese drone. Yes, we will do the best. Because we are nothing against. We hats off to the work done by Chinese. Amazing. There is no doubt. The quality of product, the cost, hats off, no doubt. But yes, youngsters like you can make India better. Great. Thank you. One of you take up some entrepreneurship because of this talk. The talk is well done. Thank you. If you have any questions. Huh? No, not only me. It is like, let me tell you, it is not easy. First thing. Okay? For example, if you have an idea now and if you say, okay, come. Technically, I can give you some suggestions. Then ultimately you need money. Money is not easy to come. Nobody will simply invest. But all said and done, the trick is people who persist, they will win. Even Elon Musk did not happen just like that. His struggle, if you see, I should tell you because a lot of youngsters are there. He started something, he was the one brain being at PayPal. He made, when he was about 12 years, he made the first computer game software, sold it for $500. That's how his business started. Then he made that PayPal kind of thing, they sold it to eBay, and those people sent Elon Musk out. The founder himself was sent out. He did not bother, he said, okay, let me do something else. He looked at that time he was studying law, he was a voracious reader. Then one day he said, okay, let me make rockets. Let me send satellites to space. People laughed at him. He said, this is something NASA, ESA, great government organizations themselves are struggling. You are a private firm and this is not selling some groceries, rocket science. He said, whatever it is, I do. He started. He got some people started. First rocket failed. Second one failed. People wrote all nasty things against him. They said this fellow is simply burning money. He has no clue what is happening. Third rocket. It went to the orbit, but gone. And rockets, it's not some investment on grocery shop. Huge. You are gone. That was the thing. Parallelly, he started this Tesla cars, electric cars. With the group, Tesla already was there, he invested there, he gave his ideas. And there was a demonstration of Tesla car. They claimed it will go more than 300 kilometers once you charge. And there is a British, on BBC there is a show where they demonstrate, motor show. In that show, Unfortunately, this car stopped at 80 kilometers. Gone. Their shares, everything came down. They thought it is gone. Parallelly, he had started solar power industry. Solar city it is called. The bank which had invested, they withdrew. We said we will not invest. To add insult to the injury, Elon Musk's wife divorced him. This is the story. But he did not budge. He said, I will do. What happened? Fourth rocket successful. Then NASA is now contacting him to help them to fly their satellites. Number two, Tesla, he became the CEO. He took over as CEO. And recent model they have released. Tesla M or something. Tesla M or something. National Highway Safety Authority of America gives rating for all the vehicles that move on the road on a 5-point. If some automobile gets 5 points, safe. That's a great vehicle. For Tesla, they have given 5.4 on 5 because he has included safety features which they had not even thought of. Therefore, it is the only vehicle to have overrated safety measure. Now, Solar City is also doing well. Tesla is something it has become, super hit. In India also they will start somewhere. So, then he started this Hyperloop, mass transportation, which can carry people faster than aeroplanes. Okay? He is thinking of circuits like Delhi to London to New York to Delhi in one day. That's the kind of thing. But anyway, futuristic, fantastic. Then he has started on this AI initiative called Neuralink, another company, where you want to embed the chips to help people suffering from Parkinson's, dementia, etc. So why I am saying this is, he persisted. Not that it was a rosy thing for him. Anyone who persists, somebody will help. Good ideas never die. You have to persist.
How will the Institute of Science help us?
Institute is a place of ideas. It's a place of ideas. Don't ask money.
No, we don't need money.
Yeah.
What I was counting the number of mangoes. Will you be able to share that drone technology or the software used in that?
Definitely we will help you.
Not even free for a price.
Whatever, we can actually work. Our lab is very, very open. You are most welcome. We can discuss. In fact, whatever we have done is all we want to just prove the concept. If somebody wants to take it further, we are there to help. No problem. We can do even hand holding technically. And then we will see. And if you have the IIC tag, maybe your funding getting fund, maybe the prospects may be better also. We don't have, but government itself has a lot of initiatives. But you have to find out, even I really don't know many of that. But let me tell you, it is not, that somebody, like they announce in newspaper, single window. So that you go with the application and they give you the check. Such things don't happen. You have to struggle. You have to have that passion. I will do. Then you will do it. So thank you for your patience.
Dr. Onkar sir, thank you very much for a very, very inspiring and informative and scholastic talk on applications of drone. In fact, many of the students who are here will be inspired to start their own startups in drones. As sir told, we should be persistent in whatever we do. When the going gets tough, the tough gets going. So that should be the mantra if you have to succeed. On behalf of all of you, once again, thank Dr. Omkar sir for a wonderful presentation. Thank you very much. Now I welcome Mr. Neeraj, a PhD scholar in the Aerospace Department, to present a talk on precision agriculture.
Good afternoon, everybody. So, first thing I would like to clarify, I'm not a PhD scholar. I'm right now working as a project associate under the guidance of Professor Omkar. I'm just a BTech graduate, and actually I was planning to do masters. Like Sir mentioned, a lot of students, the talent moving away from India. And yeah. So a lot of talent moving away from India, and then fortunately Professor Omkar inspired me to take up the work here from the lab, and then try to move it out of the research space, commercialize it, bring out few products. Like how Sir mentioned, a lot of research projects just stays in the lab. So that is my initiative. So more than educational, what I consider my talk today to be is the work that I've done under the guidance of Professor Omkar, and I'm going to dive a little bit into the technical side. Hope I don't bore you all, yeah, so I'm going to restrict to that. Before we get started, can anybody guess any of these images, where they're from? That is IISc. That's the oldest photo of IISc. I'm really bad at history, so I don't know when that is from, but yeah, I think 1960s. And this one, anybody can guess this? Middle one? Yes, there's Pandey Foundation. So we were there earlier. Actually, one of our startup initiatives that we have that I've incubated at Art Park, IISc. So we were having a discussion with the Deshpande Foundation, seeing how we can collaborate and take it further. What about this? Sorry? No. Anybody? No. I mean, it's a propeller, yeah. I would like to know where this is from. Anybody can take a guess. Sorry? No. Definitely not. This, sorry? No, this is not from HI. No. This is actually right outside our lab. This is the Department of Aerospace Engineering, Indian Institute of Science. So this is the new Department of Aerospace Engineering, and they recently painted this, so I thought I'll grab a photo of it. But yeah. So currently pursuing, actually working as a research associate and also as a consultant at Art Park IISc. I'm working on a startup initiative in the agri-drone domain. So I would like to discuss if anybody is interested in that, working on operations management, SaaS platform, and so on. But at IISc, like Sir mentioned, I have taken up a couple of initiatives and research projects, mainly in the precision agriculture, UAV technology in precision agriculture. So I'm going to come to that, what precision agriculture means. So if anybody here is, anybody has roots in agriculture, you would know how labor intensive agriculture is. So right from sowing, monitoring the growth, monitoring how the crops are growing, is there any crop stress, diseases, pest infestation. So we'll have to do a couple of round trips around your farmland every week or so. And also when pestification, you'll have to conduct pestification right after maybe rainfall or when there is some kind of infestation. That is quite labor intensive if anybody is involved in that. So you'll have to call the laborers and they don't want to work. So you'll have to wait for 2 to 3 days, get them to your farmland, and you have to monitor them because they might as well just pour some chemicals on the ground and say, I'm done with the work. So quite labor intensive. So what precision agriculture means is how do we use information and communication, technology, AI, ML, big data analytics and so on to basically help in the decision making and also help in the optimization of crop production, right? So why is precision agriculture need of the hour? So if you know, Israel agriculture is much superior than Indian agriculture. Core reason is they adopt precision agriculture like nobody else in this world. And in India, the adoption rate is quite low because they say, my grandfather said this, my father said this, that's what I'm going to follow right now. I don't want to listen to anybody of you. So literacy rate also matters. But right now, precision agriculture is the need of the hour. Reason being, population is going to increase significantly by 2050. It's going to probably hit 12 billion. That is the analysis. And you will have to increase the food production by about 50%. And India being an agrarian country, so I think it's our responsibility to adopt these precision agriculture techniques to increase that production and make an impact. And also, 58% of this country's population is mainly in the rural areas dependent on agriculture activities. So if we can actually make an impact, it's going to be really significant in this country. So coming to UAV technology, how can UAV technology be involved in this agri space? I mean, there's a lot of heat in this. It's a hot topic in the country. Government is pushing for it. So mainly because there is labor shortage in the rural areas. So UAV technology is mainly used in pestification and agrochemical spraying in the precision agriculture space. So that is the domain that government is really pushing for. Right now government has only like 2 projects. One is agriculture, second one is other projects. So agriculture being the core, the government support is really showing up. RPTOs increased double. RPTOs is basically the training center for pilots. And 3x growth in investments in agriculture or drone startups in the last 3 years. Yeah, so 600 unregistered companies are in this space, 600 plus, are quite definitely more than that, conducting agri-drone spraying in the rural areas. So they are unregistered because slightly, it's the agri-drone industry, I'm going to talk more about it, but agri-drone industry is in its infancy right now in India, and a lot of regulation constraints and a lot of unregulated work that is being going on. But definitely it's making an impact in the on the agriculture sector because I remember our team going to Hubli when we had gone for Deshpande Foundation meeting. We went around, spoke to a lot of farmers there who have taken drone spraying. Farmers who have taken drone spraying and farmers who have decided to take drone spraying, and farmers who are probably apprehensive about the drone spraying after taking it. So after talking to them, we saw that a majority of the farmers really see that impact, and they are willing to take up this drone spraying service. But that traction still needs some time in India. Definitely. So yeah, no, we spoke to farmers, so their main concerns, we can talk about this more later also, but main concerns are, one is you use 100 liters per acre of water, right? If you're doing it traditional way, you wear the knapsack and then you spray. But if you use the drone, you're using just 10 liters of water for 1 acre. So they're concerned about that, and also about what you mentioned. If you're spraying from an altitude of 2 meters or 3 meters above the crops, they are concerned about it. But we actually we try to investigate this concern. We checked if they found any impact or found any results out of that, indicating that the drone spraying was inefficient. More inefficient than the manual spraying, and they were not, they were inconclusive, so they didn't have any results. It's mostly the mindset of these farmers. So if you notice the states where there are more progressive farmers, they have adopted this solution better than other farmers, other demography. So drone uses a lot of use cases in agriculture and also in the other domains. But today we're going to be mostly talking about two topics, photogrammetry and agri-input application. Photogrammetry is, I think, probably the first thing that popped up in the UAV domain. Basically mapping the fields, 3D reconstruction of fields, extracting physical features, and crop monitoring and analytics and so on. Agri-input application is something that has gained traction over the recent years. What that means is seeding, agrochemical spraying, and so on. So let's start off with the agri-input application. So here the general workflow looks like this. So you do a field assessment. Since it's quite unregulated right now, there are not many SOPs. The teams will have to actually survey the farmland, see if there are neighboring crops that might get affected by the chemical spray, or if there is some kind of multi-cropping, or suggest what techniques to be taken. So that is the field assessment. So once that is done, you will have a flight planning. So you'll be using some kind of a mission planner software to plan out the mission around the farmland, and accordingly, avoiding the obstacles and so on. And then you load the inputs. Inputs are the chemicals. So this is quite different from the traditional approach. The concentration, mixing ratio of chemicals and so on, they are quite different because you're mixing the same amount of chemical, or maybe 70% of the chemical in 10 liters instead of 100 liters of water. So this also is probably suggested by the drone operators and the drone teams. They load the inputs based on the suggestion of the farmer and the agri-input dealers, and then you take off and conduct the operations. Now, since the drone has a battery life cycle of around 12 minutes, 8 to 12 minutes, so that is only sufficient for 1 acre of land. So, and the 10-liter capacity is also sufficient for 1 acre of land. So every acre you need to get the drone back, load the inputs, and then again you continue with the mission. So if it's auto mission, that is something that is stored in the GCS on the flight controller where you had earlier stopped, and it's going to continue the mission once the tank is empty. Right? So, a couple of bottlenecks in this industry, agri-input application. One is the technology side. So, definitely Chinese drones have flooded the market globally and also in India. So, right now, currently, about 95% of the drones flying and conducting operations are Chinese and unregulated. So even the companies who have got the certification done for these drones, they're also importing these drones and then getting the certification done for the same Chinese drones. Very few handful of companies are working on indigenous agri drones. Reason being talent, right? So the talent is moving away from India, and probably hypocritical of me to say that because I was also planning to do that, but that is the reality, right? The talent is lack of talent, lack of research development, and most importantly testing. So a lot of teams, research teams in India have conducted this research. They have come up with flight controllers, but testing is what makes the difference. So that is where China has an edge over the companies here, and that is why the adoption rate for the Chinese flight controllers. So testing, and one is the other one is the production cost disadvantage. So obviously Chinese drones have scale, so the drones that they have manufactured are much more economical than the drones manufactured in India. And so government is helping this in a way that even if the drone cost is similar and drone cost is double, but the functionalities are similar, we are ready to buy the Indian drones. But still that is not the case. The functionalities are still not matched for the Chinese drones. Definitely, the regulatory constraints, but companies find a way to work around that, obviously. Yeah, I don't want to comment on that, but then from the groundwork we have done, about 95+% of all the companies who are conducting operations are they are doing with unregulated drones right now. Mostly because of the capital investment cost. Yeah, like, much cheaper and also more reliable. And it's ironical that we are saying that Chinese drones are more reliable, but the fact is, there was one incident. I was just talking to one of the CEO of agri-drone companies. They mentioned that 4 of their drones crashed at the same time when they were flying. And that is because the Chinese server, there was some mishap with the Chinese server that the drones were connected to. And now we are saying that it's more reliable than the Indian drones, but at any given point they can just make the drone, all the drones flying in India just crash. And there was also one more incident on the defense side, when the drone took off and then landed on the other side of the border. So all kinds of mishaps can happen. That's why India is pushing for indigenous agri-drone manufacturers. But still there are a lot of black sheep in the market trying to find workarounds here. But there are few indigenous manufacturers. We are trying to get. We are actually collaborating with them to manufacture and develop advanced UAV systems for agriculture. I'm going to come to that later. So Indian agriculture conditions. This is an important factor. There's going to be a random high tension cable pole. There'll be a house in the middle. So you will not know what to expect in Indian agriculture conditions. That is the main reason for why there is such a big amount of risk flying drones in agricultural lands and spraying. So these are the couple of bottlenecks. Now the reason why I'm doing some kind of a comparison study here is to show where is the gap in the current indigenously manufactured drones and how we can work on that and get it to that stage, because government is in fact ready to invest in drones that match the capabilities but are more expensive, right? So one is definitely the flight controller. Like Omkar sir also mentioned, flight controller is something that nobody is working on or nobody has got it in the industry yet from the Indian side, right? Indigenously manufactured flight controllers. But definitely you can leverage open source flight controllers, so much better than the Chinese flight controllers when it comes to regulatory side of things. But definitely, there are drawbacks when it comes to open source. One is highly customizable. At the same time, since it is highly customizable, it's unreliable because a lot of algorithm, a lot of code that is going around in this flight controller. So I'm going to just briefly touch on the technical side here, how we can actually match the capabilities and functionalities of the Chinese drone with our Indian flight controller system. Not Indian controller, with the open source flight controllers. So you have something called companion board, so onboard computational system. So what you can do is, this is much easier. If you know C++ and if you've learned C++ and Python, obviously you prefer Python because it's just much easier to code with, so easier to learn also. So flight controller is programmed on C++, but your companion boards, there are a lot of libraries that support Python language and you can write very easy scripts for whatever functionalities that you want to implement. So you connect the flight controller to the companion board and there are certain frameworks that you can use to code the system to develop your own functionalities. One is the robot operating system, ROS. This is similar to RTOS if you have worked with. So basically you have multiple nodes running parallelly, and you can use these nodes to, whether you want to take readings from sensors or any master node to communicate with the flight controller, tell exactly what to do, how to fly, and so on. So ROS works on MAVROS. You have some protocol wherein you can communicate with the open source flight controller and give navigation commands. One more high-level framework that a lot of students and researchers can use is DroneKit and PyMavLink. So just out-of-the-box applications that you can install on your onboard computer and link it with your flight controller, and you can give commands. So let's say on ROS you want to increase the height of the drone from 5 to 10 meters. So you will have to give PWM values to the flight controller to exactly tell what motors should spin at what rate. And when it reaches that altitude, you need to get the sensor reading and say, okay, stop increasing the altitude now. But if you're using DroneKit and PyMavLink, you can just give straight away command saying that increase the height to 10 meters. So it's just much easier to work with, and definitely I suggest a lot of you to experiment with it, quite out of the box and easy to work with. So this is how we can actually start developing systems that are as capable as Chinese systems that are available and flooding the market right now. So a couple of other comparisons, the work that we have done. I'm going to just gloss over these things. Ground control station, just more user-friendly. So we'll have to definitely put in a lot of work on the UI and UX of the GCS entirely, and also the data that you get, and just these Chinese mission planner softwares are very specific to agri. And the issue with these open source is just multi-purpose. So you don't have that kind of user-friendly interface. And this is very important because most of the drone operators are probably diploma grads or SSLC graduates. And you need to have a learning curve shorter for you to have that many drone operators to be in this space. So a lot of work that needs to be done in this space. Obstacle avoidance is one more feature. And just general functionalities. Definitely, if you're interested, we could we'll gloss over these points later. So I want to get to this canopy terrain following functionality. This is super important for the Indian agricultural conditions. This is something that is not capable with any system available right now. And this is canopy terrain following. So what this means is, first of all, India is known for areca plantations and coconut. So second largest production of areca and largest of coconut. So what happens is the drone operators must be really skilled to navigate over the canopy with that uneven height distribution of the plantation crop to actually evenly spray. And since it's very difficult for manual laborers to spray the canopy of this, most preferred solution is agri-drone spraying. So here, right now, no system is available to evenly spray and assist the pilot in following the terrain of the canopies. So this is something that we are working on right now. So what we do is we have a sensor fusion of forward-facing radar, downward-facing radar. We fuse the data on the companion board. We have a couple of algorithms working on the computational system, trying to figure out what is the trajectory that the drone needs to maintain over the canopies while the drone operators are flying over the areca plantations. So the pitch and roll, basically right and left, front and back control is given to the drone, but the altitude control is managed by the flight controller. So that is how it will assist the drone operator. And most number of crashes are due to these uneven terrain of areca plantations in the industry right now. So I think this is going to make a significant impact in this space. Sorry? No, it is possible right now. Currently, how they're doing is the drone operator will stand at a distance, and there is another drone operator assisting him, telling him what height he needs to fly and how he needs to maneuver over these agricultural lands. Quite difficult, and that is the reason why there are so many crashes on these plantations. Because suddenly a tree will pop up, and then he'll not have enough time to react to it. So if you have a system on board it will assist the drone pilots to do this at a more efficiently and also with less risk. Sorry? Yeah, so you have to increase and decrease the altitude. You have to, yeah. Right. That is exactly what we are trying to achieve. Yeah. Yeah, that is what we are trying to achieve with this system. So this system, no, it's going to take control of the altitude. Autonomously, it changes the altitude over the crops. So basically you have two sensors, one forward facing to judge what is going to come in front of you, one downward facing to know what is the terrain underneath the drone, and fusing the data, the computational board will be able to maintain the terrain over the areca plantation. So let's say you want to maintain 2-meter altitude over all the crops and have uniform spraying. This is what is going to assist the pilot to maintain that. And we have built a POC of this. We are right now we are funded through some industry collaboration. We are trying to take it further. Yeah, for sure. Yeah, almost similar, but there are uneven terrain, and that is the reason for all these crashes. There are trees sticking out. You know, usually what happens is once it grows to a certain age, they plant the newer areca trees. So once it reaches 7 years or 8 years, they plant the newer areca trees in the middle of the areca. Yeah, that is when you have these problems. Right. Yeah. For sure. That's why the drone. Yeah. That's why. Yeah. No, that is the reason why drone companies, most of the orders that the drone companies get is from areca plantations and coconut plantations, because that is the difficulty. Yeah. Yeah. So, like I mentioned, second largest areca cultivator, largest coconut producer, and this is the reason why it's going to be of significant impact. So, variable rate application. So, this is another challenge in the agriculture condition. What this means is developing a system that can detect where you need to increase the agri input and where you need to decrease the agri input autonomously. So you should be able to have some kind of intelligent system to detect the crop stress and increase the agrochemical input at those regions and decrease where there is not much of crop stress. So how we do this is we first generate a prescription map. So what we do is we map the entire field and we extract the physical features. I'm going to come to that later under photogrammetry. So you extract the physical features, you determine the regions of crop stress or regions that are affected by pest infestations. And then you design a path plan accordingly to vary the rate of application. So this is something that we are currently working on, and this also works for orchards. So mango orchards, apple orchards, you don't want to spray the entire field. You want to spray only over the canopies and then move to the next tree, right? So you should be able to generate a prescription map that detects every single tree and gets the GPS coordinate of the tree, and then generate an optimized path plan around that farmland to go to every single tree. So that is what we are working on. You can use computer vision techniques for the object detection, extracting of GPS coordinates, and then optimization algorithms for flight planning. These are a couple of things definitely of interest. Lack of uniform spraying. So again, comes back to crop height. If the crop height is varying, so you cannot vary the height exactly around that. So you should be able to vary the rate of discharge of the chemicals. So increasing or decreasing the rate of discharge depending on at what altitude you are flying above the crop. And also controlling the discharge when there is no crop or in between crops. So that is something that will be necessary in the future. And also collecting data from the drone. Right now it's all bouncing back to Chinese drones, Chinese servers. So we'll have to develop systems to collect the data, sync it with the operation management platforms that we are building. So from the startup initiative side, this is what we are working on. Sloshing, this is common occurrence whenever you're carrying any kind of payload or liquid payload. So you just need more optimal flight controller and more optimal control systems to compensate for the sloshing of the chemicals. Now coming to the photogrammetry. Sorry, how long do I have? Yeah. So, photogrammetry, the general workflow, traditional workflow is you capture images using UAV technology, and then you stitch the images to create a orthomosaic or a 3D map of the farmland, and then you run analytics. So you extract the physical features or whatever features of interest, and then you run the models and analytics on that. So for mission planning, you can use Mission Planner, QGun Control. For stitching, one of the popular softwares is Pix4D. And the traditional approach to extract physical features is using GIS tools, right? So bottlenecks in photogrammetry. One is the scalable data pipelines. So like Professor Omkar mentioned, a lot of initiative taken by the government to map the agriculture and the rural areas. Now, once you map this, you have huge loads of data, and that needs to be processed. So, the stitching of the images is basically computational heavy, storing of these images, and then retrieval, and then running analytics. So, currently, there is not a single data pipeline in place on the government side to process any of these images. So probably people are working on it, but from the last conversation that we had, right now this is the main gap in the work that we are doing. So large data pipelines, scalable solutions to store data and retrieve data and run the analytics. So, and also under data acquisition, there are So we were talking to e-governance, and they had taken a couple of initiatives because they had huge chunks of data, and we had also proposed to the e-governance head. Unfortunately, we couldn't take it forward. Yeah. So data acquisition. Two types of data acquisition that I'm going to talk about. There are definitely more than this. There's thermal, there's hyperspectral, but I'm going to focus mostly on the RGB and multispectral. Reason being, this is easily accessible, economical, and this is something that is scalable given the price point and given the Indian economy. So RGB imagery usually used for farmland mapping, boundary detection, crop count, biomass detection, biomass estimation, and so on. Multispectral is slightly, you have two or more extra bands that is going to give you more information on the crop. So you can detect the crop stress. You can correlate the spectral information with early onset of disease or pest infestation. So whenever there is some kind of pest infestation, there is a release of gases. So you can detect that using multispectral imagery. So I'm going to touch on the photogrammetry sensor system a little bit, how it works. So if you have used DSLR cameras or any other cameras, you know there is a hot shoe feedback. So what that means is, as soon as you click on the shutter, there's a flash, right? How that works is there should be a very precise timing for the flash and the shutter opening and closing. So there is something called hot shoe feedback in mechanical shutters. So what that does is it releases an electrical signal as soon as the mechanical shutter opens and closes. So that is something you can use in the UAV system as well. So you can connect you have a connector that goes into this hot shoe feedback. So you'll know exactly when the shutter opens and closes. So you can get the GPS information, and that is going to give you precise geotagging of images, right? So precise capturing of images and also geotagging. So this is very important when you're trying to stitch all these images, and you want to get a very accurate 3D map of the fields. So coming to multispectral camera, usually they don't have mechanical shutters because they have around 5 sensors to work with, so electronic shutters. But you can use the similar concept. You have some kind of a trigger. It takes the GPS data, geotags the images, which can be used for stitching purposes. So this is the workflow. You do mission planning where you set all the flight parameters. flight altitude, flight speed, overlap. Overlap is basically one image and the next consecutive image. What is the kind of overlap you need? Usually 70 to 80% is what is suggested or what is preferred. Side overlap is once the UAV goes for one round and then comes back, what is the side overlap that you need to maintain, right? When it comes to multispectral, you'll have to do some kind of calibration before the flight. So all the sensors, the 5 sensors on the camera must be calibrated, so you have some kind of a board, you can see here. So that is used for calibration. Flight path planning, that's just an example how you would give some kind of grid lines to cover the entire area. And it need not be rectangle, any shape, and it's going to match that. The grid lines is going to match that. So this is one of the projects that we had taken up. It was a 12-month project. So what we were trying to do is basically build yield prediction models, health monitoring, and weed mapping models for pomegranate crop. So each crop takes a lot of time because you have to run multiple research projects on multiple harvest cycles to get accurate data and build the libraries. Right, so we chose pomegranate farm. So this is the initial survey of pomegranate farm. We selected around 11 farms in near Turvekere, Thittur district site. So once we mapped, this was a 6-acre land. Just for example, I've taken this. Around 630 trees. We had 80% overlap. UAV height was 25 meters, and the mission duration was just 11 minutes. So that is quite impressive for a 6-acre land. So this is how you use a GIS software to extract physical features. So this is the traditional approach where you annotate the data and on the raster layers that are created. So once you capture these images, you stitch the images and you create raster layers. So it can be NDVI, it can be DSM raster layer, or it can be just an orthomosaic, right? So you annotate the tree and you extract the height of the tree using the digital terrain model that is generated. Basically the 3D map. Right? So you extract the manual height, and if you want to extract the vegetation indices, so you use the multispectral data, you'll overlap the raster layers in certain combination to get the vegetation indices. So once you do that the same way, manually you have to annotate every single tree to extract the information. Right? And this is quite cumbersome and quite intensive. So that is the problem, right? Manual and time-consuming process, limited data accuracy, and lack of scalability. So that is the reason why we actually started this project. We wanted to build an end-to-end analytics platform to automate this entire process, and more specifically for orchard crops, because there are a lot of companies who have already built the software for field crop monitoring. By orchard, I mean pomegranate, areca, citrus fruits, and so on. So that is where satellite imagery cannot be used because of the resolution of the satellite. So that is where UAV imagery is of significance. So you want to, we are replacing the entire traditional manual pipeline, which is pre-processing, orthomosaic, you generate and then manually delineate every crop and then extract the features to generate an analytics report. So we replace that entire thing with a data pipeline and AI/ML pipeline. So for let's take up yield prediction for that example. So what we do is, once you have these images, we upload it to the cloud, use cloud APIs to stitch all the images. Then use AI/ML models to detect the tree canopies and extract the features, and then run it on an ML model for the yield prediction. So we use some kind of decision boundary model, and we got about 93%, 95% accuracy on yield prediction. So this is how it looks. So you have these boxes drawn around crops. This is a very simple, basic object detection model. But what you can do with that is, each box coordinates you can take up, you can layer them over the rasters and extract the terrain information. So what is the height of the crop, diameter of the crop, what is the NDVI, and then those are the physical features that will correlate with the yield of the crop. So what we did was a 12-month project. At the end of it, we collected all the harvest data manually, and then we linked it and correlated with the physical features that we extracted from these images. So this was the platform that we built, analytics platform. So you give a farmland orthomosaic, it generates all the analytics for you. So total yield, total trees, number of basically a tree count, yield prediction, and also other physical features. Again, for the health monitoring, here object detection cannot be used because if you're drawing a box around the tree canopy, you may pick up few pixels of the ground. So actually, running analytics on the ground pixels may actually affect the results. So what you do is a segmentation model. This is also another neural network model that you can train. I'm not going to get into the specifics of it, but basically it segments the trees and it delineates the crops exactly. So that you can extract only the tree information. So once you do this is how you can automate the entire process. So you detect the trees, segment the trees, only for those pixels you extract the features from the raster layers, and then you build the models to run the analytics. So this was the health monitoring POC. Again, we used only NDVI for this crop stress detection. Similar thing can be done for the other vegetation indices. Right? So weed mapping, what you do is detect the tree, everything apart from the tree, any other vegetation index, any other vegetation that you detect is basically weed. So a couple of challenges with pomegranate crop that we faced, neighboring farms. Actually, one of the biggest challenges they put a net on the pomegranate farms, so it's very difficult to capture accurate data. Especially when it comes to vegetation indices, because the net interferes with the reflection pattern of the crops. And also one more thing is everybody has different agriculture practices. So it's so heterogeneous that you'll have to build so many models and so many libraries to actually have an accurate model for any kind of yield prediction or health monitoring. So this is something that Professor Omkar also mentioned. So UAV and satellite synergy, how can we have that? Because definitely just UAV mapping for crop identification is not a scalable solution. Let's say for insurance aspects also, when there is some kind of drought or any other reasons for insurance claim, what you'll have to do is either map the entire land, map the entire district, and then give a statement on how much was the loss. Now, you can't just rely on satellite imagery because during these phases, usually there will be a cloud cover or there will be certain other environmental factors that will cloud this using remote sensing. So you need to have some kind of synergy where you map it with the UAV imagery, but you don't store all the data. You do some kind of real-time analytics. So you do real-time identification of the crop, identification of the boundary, and so on, so that you don't store all that images, which is going to take a lot of space. So that cannot be scalable, right? So you do real-time analytics and then you compare it with satellite data. Satellite data will give you, is there vegetation or not? So that resolution is enough to indicate that. Which crop and what is the boundary, that is something that you can get from the UAV imagery. That is the kind of satellite UAV synergy that you need to have. So coming to the scope of UAV technology in PA, precision agriculture. One, like I mentioned, UAV satellite synergy, and the other thing everybody is working on right now, or everybody is interested in, is UAV and UGV synergy. UGV is unmanned ground vehicles. So for a lot of applications in agriculture, you need some kind of a ground vehicle to interact with the environment. So it can be fruit plucking, or it can be harvesting, or insecticide spraying, targeted spraying, or any of those things. So UAV and UGV synergy is what is being explored right now. That is a pretty interesting topic if anybody is interested. Multi-UAV and swarm technology, for sure, to build a scalable solution. Not sure how much impact it will have in the Indian agriculture conditions because the land is so fragmented, but definitely something to look forward to. Yeah, with that, I would like to conclude. Thank you so much.
Any questions we will take in the tea break. Now we will be having tea break. Big round of applause to David Ramos for our session. Thank you very much. Now we will be having a 10 minutes quick tea break. Please join us after 10 minutes. Hello. I request everyone to check your names and college name. It will be same in the certificates. Please do not come later that this has to be corrected. Okay. Go to the reception, check there and sign and check that whether spellings are correct, institute names are also correct.
expression. Okay. Hello.
Good afternoon. So welcome to the post-break session. Now we we have with us Dr. Chintamani Pai, who is adjunct faculty of KCT College, Coimbatore, and he is the founder of Space Geek and Trilochana Aerospace Technology Private Limited. Along with him, Mr. Kashyap and Mr. Vishnu are accompanied. I welcome on behalf of KSTA and on behalf of all of us present here. So Dr. Chintamani Pai will be delivering a session on risk assessment and analysis along with a small demonstration of his drone kit here. So shall we start? Those who are outside, please come in. Over to you, Mr. Chintamani, please.
Yeah, keep it that way only. Keep it that way only because it is connected, no? No, don't remove this. Take a chair and sit, no? Keep that down. No, take this chair. Sit here. So very good afternoon everyone. So I'm also given a task to discuss the risk assessment when you are operating drones. So though I'm not a official DGCA approved drone pilot, I'm not so much experienced in this area, but whatever I could do technical review on this subject, I'm sure I'll give my best efforts so that I can convey the information to you, so that those who all are interested to becoming a drone pilot, or even if you're not a drone pilot, suppose you're carrying out any pilot project, a test project, as a student or as an entrepreneur, it's important that we should have risk assessment of the project. Okay, and as all the legends have already spoke about different aspects and risks associated with drones, especially with cyber security and what kind of problems we might face while designing our project using drones. So I think this is very much important topic, though if you don't plan to become a drone pilot. Okay, it's like any project you are doing in a company, you always carry out SWOT analysis, correct? So this is somewhat like a SWOT analysis if you want to go about doing a drone project, implementing drone project. Okay, so since I'm not much aware of the DGCA aspects, and there are no, right now, there is no document which I could study as of yesterday, which talks about details of the risk assessment definitions and terminologies. So I'll just follow some guidelines, European Aviation Safety Agency and some of the federal aviation from USA. Okay, so when we talk about the risk assessment definition, what are we talking about? We are talking about the hazard identification. So when you are flying a drone, okay, what kind of hazards do you expect? So you have to actually, people say that you always be positive, right? But in case of drone technology, I would recommend that always think negative. What kind of hazards you are going to expect? Okay, only when you understand those hazards, you know what are the risks you are taking. And when you understand those risks, then only as a technopreneur or a researcher, you will understand how to mitigate those risks. Okay, and it's very important whether you're a drone pilot or not, whichever drone model you're using, you must have a documentation whenever you're carrying out a pilot project. okay, or pilot study or a research project. Okay, yeah. So part 1, as I said, is a safety hazard identification. You need to identify the safety hazards. Okay, if there is a near miss, whether your drone is going to collide with a vehicle or a building, whether there is a probability of falling on somebody's head. Or I just want to slightly deviate from the topic. There is a possibility that the meteor falling from the sky can also fall on your head or on your car. So in some countries, the insurance companies also cover those aspects. Okay, so similarly, of course, the meteor falling on your head or a car, the probability is much less than a drone falling on any vehicle, colliding with a building. So you need to have these assessments, and after these risk assessments are done, you estimate a probability. Okay, some probability, there are ways to calculate the probabilities and how you go about mitigating, and of course the documentation. Because we also have some experimental demos, so I will quickly go through this. So what kind of safety hazards you might face while using drones? So you can have high loss of altitude. Your drone, you are using it for photogrammetry purpose or remote sensing purpose, and suddenly maybe there is a cyber attack, or suddenly battery is drained, okay, or GPS signal is lost. Suddenly it will have high loss of altitude. So depending upon your area where you are operating these drones, have you assessed what kind of GPS signals, how accurately you are getting, how precise GPS signals, what is your signal to noise ratio, you need to assess. Okay, are you operating these drones in the line of sight, or it is going beyond visual line of sight? So of course in India nobody is working so much in the beyond visual line of sight, so basically this probability is slightly less, high loss of altitude. Loss of control, okay, sometimes your controls don't work, so you need to have a backup. So it's all about the project management, you know, as if you're working in a corporate domain, how you go about having a SWOT analysis of any business project. So in the similar aspect, a drone pilot or anybody working, anybody making use of drone technology needs to identify these safety hazards. So loss of transmission, collision with, as I already covered this, partial failure or loss of navigation systems. Sometimes during cyber attack, as Puranik sir told, one can actually nearby area, one can spoof GPS signals. So your GPS signal will receive latitude, longitude, which is not at all connected with your area, and suddenly drone doesn't know where to travel. Okay, and then if your flight program is not so intelligent, drone doesn't know where to fly, and that is where you start worrying what is happening. I'm giving my GPS signal, but there is somebody who is spoofing, okay, GPS signal. So you need to identify such possible negative worst scenarios, and by identifying such negative worst scenarios, you try to reduce your failures. Okay, like as in Chandrayaan 3 success, ISRO chairman said that we are not looking at success, okay, successful landing, but what we are trying to do is trying to mitigate the different levels of complex failure possibilities. In what ways we can have failure while having successful landing of Chandrayaan, and if we are able to mitigate those failures, we are ensuring that we'll reach there. So the same approach you should have while operating drones. If there are severe weather or climatic events, make sure that you are having a good weather apps, or there is a prediction, you know, you have apps which are actually give you quite precise weather predictions in that area. So you need, because if there are gusty winds, those gusty winds will, your trajectory will be having uncertainties. Then existence of corrosion, if you are working in coastal areas, because of the salt present in the air, okay, that might affect your components, so you need to keep checking the components regularly. Okay, pilot has to be familiar with the area. If you're not familiar with the area, okay, it is like you're entering in dark forest, you don't know how to go about. And then after setting up the trajectory in your mission planner, then you realize, oh, this is, I should have thought about it. It should never happen. Okay, and the precise, the safe takeoff and landing. Okay, and avoiding any incidents such as undershooting or overrunning. Going next. So there are always limits, whichever drone you choose, whether fixed wing or multi-rotor drone. So talking about physical limits, you can always have maximum takeoff weight. So accordingly, you have to choose your sensors. Okay, if your sensors are very costly and heavy, but if your drone is not capable of lifting them, okay, and the trajectory at which you want to carry out the spatial scan, okay, if it is not achieved, then your whole mission planning will go in vain. Okay, the temporal limits depending upon your batteries, the time of flight, response time, what kind of commands or acquisition time of the sensors, then of course environmental limits I spoke about, then behavioral limits. Okay, the pilot behavior, you know, I mean sometimes if pilot is stressed out, okay, are you on autopilot mode or actually manually you are controlling the flight? In fact, FAA guidelines actually talk about whether even the pilot is in, you know, is having, you know, mental stability, because there are some complex maneuvers you might have to do, okay, based on your project. So you need to be very mentally, you have to be very peaceful, alert, aware, and that will result in a good maneuver of the drone. The networking limits, okay, network delays, communication delays, okay, and how the jitters are coming because of the maybe weather conditions or inherent motor problems. We will show some videos where we have actually tested in this campus itself. When we were working on some of these frames, we actually came across a jitter. So how to choose a stable and unstable frame. We'll also give some demonstration on that and some recorded videos. And your sources which can cause problems to you can be external, internal, okay. So internal can be mechanical, your frame is not correct or frame is slightly having a defect, or in previous operation it had a damage but you did not noticed it. So as a drone operator, it is like you are having a fighter plane. All fighter pilots, they take care of their fighter planes like their family member. Okay, every very small area also they remember if something has gone wrong in their previous flight, and that is how these fighter planes are maintained. So in the similar manner, you have to take care of your baby, okay, your drone. So any small mechanical damage which goes unnoticed can have very bad consequences. Then the thermal aspects, weather aspects, okay, at what altitude you are flying, what are going to be possible, the temperature deviations, temperature gradients, is that affecting your sensor performance? Because if you have simply referred a data sheet of any sensor, it always gives you the temperature extremes in which that sensor work. And if you're typically working with the thermal camera, there are thermal currents at the pixel level, and those are dependent on the temperature of the environment. So when you are doing a very sensitive data analysis, by sensitive I mean if there are going to be signal to noise ratio kind of aspects associated with the thermal imaging, you need to understand at what kind of temperatures are expected at that altitude, and are there going to be any, because of turbulence in the air, are you going to expect any temperature variations. Coming to the electronic aspects, you can have a propulsion failure, there can be saturation, power loss, algorithmic. In your lab, those algorithms are working fine, but when you actually go on field trials and you are taking your drones to extreme limits, you realize your algorithms are failing, and that might result in some huge loss. Your costly sensors can undergo free fall. I mean, typically electro-optic sensors, if you're working with, those electro-optic sensors cost somewhere around 1 crore, okay, typically in the range. And if you're not having an assessment of your flight algorithm, and if something happens, your whole 1 crore is gone in single flight without any utilization. So you have to be very thorough with your drone, and you have to maintain it. You have to see the worst case scenarios. You have to think negative. What negative scenarios you can expect. The software, you always work with different kinds of softwares. There overlap, maybe multi OS systems. There are softwares with multi different OS requirements, different firmware. So you also need to have an understanding of that. If your firmware is upgraded, if there are any bugs, if there is not proper handshaking of the software with the sensors. So all these things you need to take care of. CPU error, avionics hardware. So what is a risk? So safety risk assessment is the fundament of a safe drone operation and instrument for continuous improvement. So once you have identified possible hazard for one project study, doesn't mean that you have to stop there. It's a continuous, it's a continuous process, because every time you go for new mission operation, new mission, so the hazards might change, they might reduce, they might increase, there can be complexity levels might change. So accordingly, your hazards keep continuously changing, and accordingly you have to decide the action and what are the risks. You are actually, every time there is a risk. Whenever you are flying a drone, it is like flying a rocket. Okay, the astronauts, every time they are sitting inside a rocket going up in space, they know that they are sitting on a huge bomb. So similarly, when you are flying a drone, okay, however small it is, there is always a risk, and you have to take care of that aspect. So once you have identified what are the possible hazards, then you further go on classifying them. So what are the likelihoods? Okay, how frequently you are facing particular hazard, how occasional it is, how remote, how improbable, how extremely improbable. And once you are having such a likelihood, with that likelihood, okay, what kind of damages you might have if that likelihood actually occurs. So you have to create a mind map in which, for a particular drone based project study, you have to identify, you have to classify your hazards in this manner. Okay, so once you have identified your safety risks, safety risk severity, and so you can actually work out a scoring matrix for your drone project, and accordingly you know what are the possible scenarios. These are all combination of scenarios with the likelihood and the kind of hazards. Okay, any hazard can have a less likelihood or a larger likelihood. Okay, so accordingly one can create such a scoring matrix where the red, which means certainly if you are coming across this possibility which you are seeing, it is not acceptable, you should not fly your drone. You have to thoroughly go back, okay, mitigate these risks, and then only come for the flying the drone. Okay, and the yellow is tolerable but requires risk mitigation. Okay, and the green is at acceptable level. So you know, okay, if this is a minor problem, okay, we can plan the drone flight. Okay, so these are the so as I said, yeah. So if you fall in the acceptable region, okay, no actions required. If it is tolerable, yes, it has to be mitigated. Okay, and so that practically you can safely fly the drone. And if it falls in this region, yes, you have to stop there. You can't fly the drone. There is serious problem. You have to completely remove that possibility. Okay, so these are the typical kind of hazard categories you can have. You can have a technical issues. You can have issues with the external systems due to human errors. Okay, you can have, if you're part of a film shooting crew, you're continuously shooting aerial shot, continuously taking aerial shots, then crew might undergo fatigue, mental fatigue. Okay, that is the human error, and because of mental fatigue, I'm not able to control the drone properly as expected. So you need to have these kind of aspects also to consider, okay, because the human error, however it might look with the other technical challenges smaller, but it can be disastrous. Okay, going next. So this is how the approach, and then once you have identified the possibility of hazards, your task is how you go from high risk to low risk depending upon the possibilities of hazards. So I'll quickly go through. So depending upon your external and internal sources, you have to create a model for your drone. Okay, what kind of hazards you might face and how you can, which will ultimately lead to crash, and you have to avoid crash, okay, or any other damages. And accordingly you have to create your own scoring metrics for your drone flight. Okay, so once you have identified possible hazards, you have purchased a drone. Let's say you are using it for more than a year or more than 6 months. You should always have event logs for your drone. I recommend, even if you are not a drone pilot, you have your own drone, and you are wherever you are utilizing it for your experimental purpose, okay, or maybe for a technology project. With every project, with every usage, you should always note down which things went wrong, how you mitigated them, okay. And in principle, with time, you will have your own probability distribution with kind of hazards you might face with your drone models, okay. And so one can then come up with what is called as a tornado graph, okay, with a estimating what is a crash probability for your specified project, okay. So I think so your whole UAV safety risk management process, it revolves around all these: what are the root causes, what are the hazards, what are the root cause of those hazards, then you assess them, you mitigate them, and then you come up with the implemented actions. In principle, then you nullify those occurrence of those hazards, okay. And as the policy is continuously getting revised, drone policy, so I think for any drone pilot, it is as good as maintaining an aircraft. So it is always required that the policies which are being made or the recommendations which are sent to the government, I think it's always easier to follow these kinds of databases which are associated with the aviation sector. Typically aircrafts, they always have safety and flight reports, okay. NASA has developed its own aviation safety reporting system. Whenever astronauts go, how actually you verify all the aspects before flying, even before just 30 seconds of the rocket taking off. If something is going wrong, one parameter, okay, the whole control system is made in such a way that it will send a message to decision maker, okay, that whether what is the probability of this takeoff, whether it will be successful or there will be failures, what kind of failures, what are the complexities, okay. So I think, yeah, so I'll show this at the end of my talk. And going back to what I actually started, so we'll demonstrate a drone flight to you. I'll go back to my slides on day 1. Yeah, so this is where I stopped last time. An issue. Yeah. So this is where I stopped last time because of the time constraint. So I'll take it now from that slide. So whether you are undergraduate, postgraduate, or a research scholar working in drone technology or aspects of drone aerodynamics, you can always design in-house experiments, because since I am experimental researcher, I believe in experiments, what I see with my naked eyes, okay. And so if you want to study the propeller system. Okay, you can have a drone flight computer which is connected to the electronic speed controller which is controlling the rotor speed. You have a 3D printer, you can design different kinds of propellers and see how these propellers are actually creating a thrust. So these tabletop setups one can create at their own homes if you are passionate about drone technology. It's not a rocket science, so these are quite easy to build. Yeah. So when we are talking about the applications of drones, be it surveillance, exploration, rescue or security, the drone aerodynamics is always connected to these fundamental aspects. One is a computational fluid dynamics, how you are able to simulate the drone flight, its structure, what are the stresses being created, what is the airflow around, whether it is creating any vortices, turbulence, making the drone flight jittery, and the mechanical stresses being created. So you want to analyze the performance of a propeller, or if it is a new frame, newly printed 3D printed frame, you want to see how the porosity is affecting the drone dynamics. All that can be studied in CFD, but it is not just, generally I see that engineering students, they are happy with CFD. Once they have created very colorful plots, they are happy that they are able to present it in the conference, publication is guaranteed, so and nothing takes off after that. But I think more than that, you should couple with these aspects. So one is the particle image velocimetry techniques, okay, where you can actually experimentally study the airflows, how those airflows interact with the drone frame, and you can come up with your own experimental aspects, be it related with drones or the sensors on drones. Yeah, those are thrust experiments. So you have the Pixoc flight controller, and you have the electronic speed controller which is connected to your thruster. Now you may, depending upon, suppose as you are doing your work, you might go for a new kind of propeller, right? You want to see how that propeller performance is at certain altitude. Then you can actually have such in-house system where you can put a new propeller. Yeah, that is a load cell, okay. That is called as a load cell, okay. And that load cell gives you because if there is a thrust created, automatically the component of gravitational force is altered, right? So accordingly, your load cell actually measures the load in the vertically downward direction. So you can design your own flight computer programs, and the way you want to control or test your algorithms to control the rotor RPM, and you can develop such systems in-house. So coming to aspects of how these flight controllers actually work. Okay, so I won't go into the details. So one is actually the physical system. This is your actually the PMSM, the permanent magnet synchronous motor. It can be BLDC or BLAC, and this is controlled. Suppose let's say it's a 3-phase motor, and it is actually connected to a voltage supply through a power inverter, and then you actually have the physical system which measures the position. It is actually capable of measuring the rotation of, so any motor is always going to have a back EMF, okay. So depending upon your back EMF, measuring it, whether you are measuring the voltage or a current, okay, you can actually calibrate your system so that even if you do not have the other sensor input, the system itself will act like a sensor, and you are able to actually measure the degrees. So at a given time, what should be my orientation of my blade, okay, and that is what actually how the electronic speed controller works. So if you want to design your own electronic speed controller, I think there is a way you can do that. And so what it will do, it will actually at different, if it is a 3-phase motor, it will take the value than expected, and accordingly a closed loop system can be created so that you can give those, so you have the omega reference expected, and accordingly you generate the reference current, because you know now the difference through back EMF, and accordingly even if the command is given to have the RPM at that number, okay, you know it is that number, but it's not actually rotating at that number. So accordingly that can be adjusted in real time. Okay, so this is a typical by Texas Instruments. This is actually the block diagram of the current controller system for the propellers. Then this is by ST Microelectronics. These are the current the electronic speed controllers. And when you have a flight control board, so this is how the individual, whether it is maybe a pulse width modulation or CAN interface or I2C, you can actually connect these electronic speed controllers to your individual propellers. So coming to the aerodynamic aspect, once I have the such in-house system to understand what kind of how I'm able to control the RPM of the propellers, then the next level task one can look at is simulation. So you have the control, you define a model, and you are trying to understand what kind of pressure zones are created because of the thrust of the propellers. What is the airflow? Is it creating any vorticity? Okay, and for your drone model, if you have for your drone, if you're having your 3D model, you can actually carry out a CFD simulation, and you know what are kind of risks you have. Depending upon, you create actually the test scenarios. Okay, so this is typical simulation from one propeller. If it is this is a overhead view as it is rotating, how the flow patterns are actually created. So what you actually do in CFD, you can actually do in-house experiments so that you can actually visualize these patterns, and that is, I think, very interesting for anyone who is interested in drones, how these flow patterns can be visualized. Okay, so at different RPMs, so if DJI Phantom, if I carry out the simulations, these are at different RPMs, you can see actually the airflow. So if you actually keep a camera laterally and you're recording, you can actually, you can see the behind scenes are actually, they are not clear because of the airflow. So these are the typical in-house systems. This is another setup which you can create. This is your load cell. Okay, this is your propeller which is kept in vertical direction. So you, based on your RPM, the load cell will detect different thrust. Okay, and suppose these are costly systems, you can simply buy this 150 rupees pulse width modulation, which will actually demonstrate. We have it. So, suppose there is a funding issue, right? So one can simply buy these 150 rupees pulse width modulated chip, do the experiments, okay, at your college, at your home. So if I'm moving, if I'm having the different RPMs, what kind of velocity magnitudes I'm creating, okay, below the propeller, and that helps me to that helps us to understand what kind of overall thrust drone is generating. So, and if below the propellers, okay, you can see as you move away from the propeller, if this is the axis of symmetry, you can actually work out the radial profile. So what you're actually simulating can be also experimentally measured. In fact, I will show you here later. If you're interested, we will show you actually how to measure that. I'm carrying the system, okay? Because of the constraint on time, and I'll quickly move ahead. So sometimes you can do very interesting experiments. If you're depending upon your drone frame, you want to understand, okay, how the propellers, propellers which are in the neighborhood of each other, how they're interacting. So as they create these wind profiles, okay, below them, there is a possibility that these wind profiles will also interact with each other. That might create instability. So if you're working on manufacturing of drone frames, your frame design, okay, so you need to have some understanding of how these air wakes are actually created. There is a possibility of interaction of these air wakes, and how these air wakes, their interaction is, is affecting your drone stability. Okay, and these are the wind tunnel studies one can have. Okay, so you can actually mount your propeller connected to load cell. You are providing certain PWM signals. You can control RPM, and if there is an airflow, you know in that airflow how these is there any issues? What kind of airflows, vortices are created around the propeller? Whether propeller at certain airflows, because you can have situations where you are having gusty winds. So in that scenario, whether the given RPM, what actually the command you are sending for given RPM, whether it is that RPM or not. And you can develop these kinds of PIV laser systems. Okay, you can purchase the proprietary systems, and you can actually study the flows in real time. So you can mount propellers in different orientations, okay, to simulate different experimental scenarios. And coming to other aspects where if you want to study real time the drone dynamics, you can have the optical motion capture of drone. Now what is that? Drone is used for actually capturing. So what do you mean by optical motion capture? So there are these systems being developed where I can actually mount certain sensors on each nodes what I'm interested to study of drones, and at different scenarios, okay, they actually give me a millisecond scale data, okay, and these are the systems being developed by for military, developing military drones surveillance applications. So you can develop such in-house system where you can having these motion capture cameras, you have a tethered drone, and as you can see there are these nodes created, and these nodes give me in real time millimeter scale vibrations I can study of drone frames. So you can create such a experimental zone, okay, and very few labs in the world right now are having this facility. Only the military facilities are doing these kind of experiments. So if you're talking about the swarm drones, okay, how they are rotating, okay, if there is an airflow generated, okay, how they react to airflow, if there are millimeter scale variations, how you can actually study those. So what we are working at, we are actually developing such drone based platforms. As I spoke about the risk assessment, we are actually, we have a product to offer. So we are in high seas. Suppose you are having such 1 crore systems, electro-optic systems, you are doing surveys. So you need to take care of the smooth landing of drones. So I'll show you the videos. So you can see even the vessel is, okay. So you can clearly see here, even if the vessel is moving, the platform is stable. So which ensures that I have very smooth landing of the drone. So I'll show you some studies, other studies which we are carrying. Okay, then yeah, through foreign collaboration. So we have actually contributed to the algorithmic aspects. So then I go to drone tracking, the comparison of drone frames. So we actually just recently fabricated new frames and we actually tested in the campus. So you can you play again? Yeah. So you can see one drone, one frame, how unstable it is, it falls down. Can you again play? Yeah. And the other frame, see how stable it is, see how unstable it is. So you can think of your own architecture for creating frames. You can develop your in-house experimental setup for drones. Okay, then go back to slide. Okay, yeah. Okay, so this is how it nullifies. This is how it nullifies the motion in real time. So the applications are not just related for the drone landing platform, but there are other several applications we are looking at. So if your car is, if you're carrying out a mining survey, and if the terrain is not smooth, it allows the drone to safely land. Okay. Then we are also developing some experimental test systems for detecting underground buried objects, because there are a lot of areas where typically border areas where even our own men, once they deploy the mines, because of the interstitial geological movements, the mines actually get displaced from their location. So even if you have a precise GPS tagged mine map, you don't know when you are actually demining that zone where actually that mine is. So there is a requirement, and if generally the work is being carried out by personnel and they suffer, there are lots of casualties. So there is a requirement that drone based detection of such things, we are developing sensors, not the drone. So we are looking for we are open for collaborations where if somebody is interested to collaborate for the drone aspect, because again that requires some mission planning, and once you mount these sensors, we are able to detect these underground buried objects. So these are some of our results for detecting underground buried objects. Then we are also developing smart camera systems which can work in the harsh weather environment. You can actually penetrate through harsh weather conditions, and for anti-drone technology, how one can real-time track the drone. Because imagine you are having airports, and even a small nano drone enters in the airport zone. How you will able to detect it before it knocks down any aircraft engine, or it collides with the aircraft which is taking off, or either which is yet to take off. So there is a need for anti-drone technology as well. So I think I'll stop here, and maybe we'll quickly demonstrate the drone flight. Thank you. If there are any questions, I'll take. Yeah, I think it can be developed. If all propellers fail, you can develop a smart parachute system. Yes. Yes. Okay, I think we demonstrate drone flight. Okay. So it's my pleasure to introduce my team member, Mr. Vishnu Verma. So this is one of our models which we use for the in-house experiments and also for the educational purpose. Okay. So the whole aspect is actually to show you how the drone flight is. So keep it at that just keep it. So now you can clearly see here how stable it is, but now if it moves forward, take it up and move it forward on that side. You can see if it has to go forward, it has to tilt. Okay, so what I was talking about, actually the thrust, you need to have the unbalanced force in one direction. Okay, so maybe if one of you would like to try, you can come and try. You can take it ahead, na drone, flight ahead. Yeah, just 5 minutes. Sorry for taking your time between lunch, but I hope you all like this talk.
We have one more session after that lunch.
So maybe you can just try. There are no fans, right? So right now it is doing up and down motion, but as you see, it is flying. Okay, nothing will happen. It is very safe drone, okay? It's meant for kids, so don't worry. So as long, you can see that as long as it is moving, that's fine, okay? That always happens. So as long as it is moving, okay, you will always see that the drone frame is tilted. Because generally, you yeah. Stuck. So it will come down after battery drains. So now you realize that you have to become a drone pilot, right? So you can see the drone vulnerability, right? Yeah. Okay, thank you. If there are any questions, we can have it during lunchtime.
Thank you, wonderful. Thank you, Chintamani ji, for a wonderful session on drone demonstration. Now we have with us Mugilpiru Ramaswamy, co-founder and CEO of Skylark Drones. On behalf of KSTA and on behalf of all of us present here, I welcome you, sir. Please. Minutes session. After that, lunch break, and again the session will be continuing. Please raise the curtains. Just 2 minutes. Only one generator on over. It is connected only for light purpose. It is connected. Hello. Mugilan Thiru Ramaswamy. He is a co-founder and the CEO of Skylark Drones. He has finished his engineering from RV College of Engineering, and post that he has done his Masters of Science in Aerospace and Aeronautical Engineering, Purdue University, and after that worked as a graduate student, and in Project Vyoma he has worked as Chief Design Engineer. After that worked as a board member of the Academic Council in RV College of Engineering, Bangalore, and currently serving this startup Skylark Drones as a full-time CEO and co-founder. With this brief introduction, and he is having 10+2, almost 12, more than 12 years of experience in drone product development and service management. With this brief introduction, I welcome you, Mugilan Thiru Ramaswamy.
Hello. Yeah, it's working, I think. Perfect. Great. First of all, thanks for having me here. I think I need that light changer. Okay. No, that's okay. I'll do it myself. No problem. Okay. So great. So I think we had a great session with the drones flying, right? Not going to take too much time before lunch break. So I have a couple of sessions planned, as you guys have seen, right? Number one is quick on little bit on payload and applications because of payloads, right? And the second one is on data analytics. I think that will be post lunch, right? So I am going to take second session will be a little bit more interesting. I'll show you some software, some cool things that we can do with drones, right? I don't have any payloads with me at the moment, but I'll quickly run through a whole bunch of things from our experience, what are applications possible, right? Would love to have it in a little bit of an interactive session, but you know, I'm gonna just quickly run through some of the things about drones and what drones can be possible. So yeah. So very quickly, you know, as you guys already know, what are drones, right? It's just a robot which can move in 3 directions. So they become useful basically when they can carry payloads, right? Otherwise, you know, drones have been around for quite some time, right? And I think they become very useful when they carry some payload of sorts, right? Or they can, you know, deliver pizzas, right? There are only 2 major uses, right? So why is everyone talking about drones in the last decade or so, right? Drones have been around quite some time, but people have started talking about drones very recently, right, from the history. So what has happened is the fact that there is, you know, more reach that is possible. What that means is basically that, you know, if you're standing here, drones, typical normal drones that you can purchase, you know, off the shelf for about 1 lakh, 2 lakh rupees, can go up to 14 kilometers, 15 kilometers from where you are standing, right? And you can possibly extend it up to 30 kilometers also, right? These are commercially off-the-shelf drones. You can go buy them, you know, anywhere you want, and that becomes extremely useful for people. So for most of humanity, we have all been restricted by, you know, this room where we can talk, we can see, etc., etc. Right? For the first time, you know, everybody in this room can potentially have a reach of around 30 kilometers, right? So what that does is the fact that it kind of drastically improves the productivity of anybody, right? So as a human being, if you have, just like how productivity improved with mobile phones and computers, you know, if you have a drone which can go 30 kilometers, automatically, obviously, your productivity increases, right? So typical, you know, use cases around, you know, anything mining, land survey, anything at all, you can collect about 10 acres of data in just less than a minute, right? Which is never fathomable before, right? It drastically improves security. So suppose some of the use cases that I'll show you later, you know, for example, if you want to have, you know, just a monitoring around your, you know, this campus or a rooftop or something, it becomes almost extremely easy to do this right now, all affordable by anyone of us over here, right? So drones basically are, some confluence of reach, security, and productivity. That's what the technology actually provides, right? So I'm going to very quickly, show you what are the things that, payloads can enable. One or two applications only, right? So I'm not going to, stretch too much on this, right? From a mining standpoint, number one is, I'm just going to talk about a mine. This is about 6 years ago itself, we collected data of 8 acres per minute. That's how quickly you can do surveys, right? Takes only 1% to do this survey actually, right? This is the output you get. We will do some real time, maybe next session I will show you how to create this map, right? But this is the map we created. Each one of these maps of a particular mine is about 1 or 2 centimeters per pixel resolution, which basically means to say that if you are standing on this mine somewhere, we can possibly measure your t-shirt size, right? So that's how accurate data is possible, right? This is the elevation map of the entire mine, right? It kind of shows what is the elevation of this entire mine, the pit, and wherever they're excavating, right? So kind of helps in providing how much volume they're excavating of a mine and whatever else, right? This is a slope degree of the same mine. What it means is the fact that we can potentially know where the water is going to stagnate in a mine, right? So essentially you have a slope map of the entire mine, helps in knowing where water will stagnate, right? Again, corridor mapping, this nothing but railways and highways. So recently NHAI and other government bodies have started taking notice of this technology, right, as you could read in some newspapers, right? There are about 1 lakh odd kilometers, 65,000 odd kilometers of railway lines and Indian roads. It could possibly be done in about 3,000 drone hours, right? You can map the entire thing. You can have a digital repository of all your highways, which we don't have today, right? Could be done in less than 3,000 drone hours, right? So that's what drones can enable, right? So very quickly, what we have now, this is what everybody, including us as civil engineers or anybody, engineers would have. Everybody knows this kind of thing, right? You have digital CAD models, right? AutoCAD, but this is what you kind of get afterwards. So I'm going to just quickly zoom in. This is the ortho map, right, of all the trees, and we can build. We have already built algorithms on tree counting to actually count the number of trees next to the, this thing. So these are all automatically digitized of sorts, right? Again, rooftop solar. So one of the things that we are working with some of the other customers, is the fact that when you are actually, I don't know how many people here have solar power panels on top of your roof, right? But one interesting thing is the fact that if you're going to purchase new solar panels, hopefully in the next 3 or 4 years, right, what is going to happen is mostly today people are going to coming to your roof and actually measuring using tapes, right? So what we have enabled currently is the fact that, and mostly all other drone service providers will enable in the future, is the fact that everybody, a solar service provider who's going to come and install solar panels on your roof is going to mostly fly a drone on top of the roof. You're going to get a 3D model of your roof in 30 minutes, right, flat, right? And which basically means you don't need to again possibly do any sort of measurements, right? And this is done extremely cheaply, right? He's carrying a commercially off-the-shelf drone, which is, I'm guessing, lesser than an iPhone in price, right? And you can possibly measure a rooftop, right? So another interesting payload which we did long time back, somehow didn't take off, was your smart metering. So essentially everybody has smart meters. People have RFID. That's how they collect electricity meter readings. So this is another interesting payload you can put on top of drones. Maybe in the next decade or so, you can possibly fly drones on top of every single area, right? And you can automatically collect your meter readings, right? Even if there are no internet connections, etc., etc., your RFID will basically have have a 20-30 meter range from top of this thing. So you can possibly collect all your meter readings from places where there's no internet connection as well, right? So that's another thing. So, but anyway, so I'm just very quickly going to show you, what are the applications which are possible, right? This is a laundry list from infrastructure, security, utilities, forestry, delivery, insurance, livestock, agriculture, right? So these are the list of applications which are possible. Each one of them having you can, and this is, you can keep imagining newer applications, right? So I'm just going, this finally my topic. This is where I'm going to spend some time on, right? So these are the payloads which typically people carry, right? There are about 6 of them, right? And I'm going to very quickly run through each one of them. I think everybody knows most of it. These are things which are, done using a typical camera. I mean, not whatever you have seen here are mostly camera-based applications on drones. So if you notice, these are all the applications which are non-camera based, right? So let's start with the most simple one, right? This is the thermal infrared imaging, right? So this, whatever I'm showing over here. So as people will already know, right? So this, you can use thermal, things. I've listed only 3 things over here. Can someone tell me what else can you do with a thermal camera? Why they're basically wildfire, and you can read this, right? But other than these 3. What else do you think we can do with a thermal camera on a drone? Okay, animal tracking. Sorry? Okay, engine temperatures. Okay, then oil leakages, trespassing. Then anybody else? That's all. Huh? Okay, so that one other thing I will tell you, one thing which is already there. So most solar panels today, right, are not really done with respect to, manually go measure temperatures on this thing. Solar panels today have some sort of a defect, because they do come up with defects, and you can actually measure the hot spots on a thermal panel using this and a drone, right? So today we have like few hundred acres, like 150 acres, 200 acres. This is a normal average size of every small solar park, right? That has around easily about 1 lakh panels, right? So if you are to go individually with a camera, 1 lakh panels, it will take forever, right? So essentially that's an interesting other application of this thing. Other application is mostly on electricity lines, right? So when you have electricity lines, there are cases where there is overheating which are possible, right? On especially in the conductors, right? Other than corona discharge, so essentially you will want to have some sort of thermal monitoring. Other than all these 3, every application what you guys told is actually right? So let's move to the second one, right? So we did thermal. Next is hyperspectral imaging, right? So these are lists of applications, but no, everybody knows what's hyperspectral here. Anybody can tell what is hyperspectral? Okay, so I'll tell you what's hyperspectral, right? So basically, thermal is when what you are doing with thermal is you are basically measuring temperature of this particular thing basis whatever some light which is getting emitted from the body, right? That's basically what thermal. So, but unfortunately, and your cameras are measuring only R, red, green, and blue, right? So hyperspectral is a same sensor which kind of absorbs 16 different light waves, right? It has different wavelengths. So most cameras have a simple sensor which has only red, green, and blue. That's why it just takes those this thing. But hyperspectral will do about 16 of them. So any object over here will kind of emit light in different wavelengths. We capture only red, green, and blue, right? But hyperspectral will capture 16 different wavelengths of what it emits, right? So that is the beauty of hyperspectral imaging, right? So as any one of you guys would know that if I am going to absorb 16 different wavelengths, of course I can do a lot of analysis on that, right? Lot of correlations possible, right? So some of them are here, right? You can do crop health, you can do mineral prospecting, whatever. You can do a whole bunch of things, right? But I'll give you one very interesting example, right? So hyperspectral imaging is what people do before using bigger aircrafts, but now using drones to actually find out where diamonds are for diamond mining, right? So if you want to find out where, you know, any sort of mineral, especially which gives out diamonds and so many other things, they basically give out, you know, different types of wavelengths of light in a particular region, right? And you can possibly use hyperspectral to discover them, right? So mining is the one of the biggest, you know, use cases of hyperspectral imaging, right? Then quickly I'm going to go to LiDAR. Everybody knows what's LiDAR? Anybody can tell what is a LiDAR? Okay, perfect. So good, everybody knows, at least somebody knows. So I'm going to quickly tell you what is LiDAR. LiDAR is nothing but, you know, it's a simple sensor where you just put, you know, light to a particular object and you reflect back the light and you measure the distance, right? That's as much as what LiDAR actually is, right? So, but where it's used, typically these are the things like topography mapping, tree canopy, tree height and all of that. But I'll tell you very quickly where it is being used, right? Can anybody tell me where LiDARs are being used if you put it on a drone? Land measurements. Anything else? Anybody else? Okay, so I'll quickly tell you what other applications on, you know, LiDARs, right? So yeah, plant height. Yeah, plant height is a good one, right? So LiDARs are typically used when you can't, you know, when you see when you take a photo of something and you can't really see what is behind it because it's very dense vegetation. You know, a laser light can potentially go through a tree and hit the ground and then get it back up so that you'll know what is actually in the ground in a dense forest region, right? Because when you have dense forest, you'll never know what the height of, you know, things are, right? So you'll want to put a laser light so that you can measure the height. Very interestingly, what is possible using a LiDAR, right, is what people are going to do, not yet done because it's a little bit more expensive, but what is going to happen is, you know, all your road construction. When you talk about road construction, what happens is typically contractors are being given, you know, mandates, right? You're supposed to use some 1 centimeter, 2 centimeter, 1 mm of the bitumen layer which needs to be put, right? Now, how exactly are people measuring this exactly? Not as much, right? So essentially, and hence there are a lot of potholes, blah blah blah, as you know what the effects are, right? So essentially what you can do with LiDAR is basically you once there is one layer of road being put, you can actually measure the difference in height and hence show rather how much is going to happen, right? So sorry, right? So that's on LiDAR. Next I'm going to quickly go to gravity meter. So you guys know what is gravity meter? Yeah, sorry. Correct. You have to run the entire, you will fly a drone on top of the road, right? Not on the road, fly. You can fly at 20 meters, 30 meters, depending on the resolution, above. You don't need to run it on the road at all. So that is the advantage, right? So essentially what happens is if you are laying 200 kilometers of road, it will take you only 4 days to cover everything, right? So, but very quickly you can find out, right? So, okay, so very quickly what I'm going to do is gravity meter, right? So guys know what is gravity meter here? Anyone? Okay, so gravimeter is something which typically measures the gravity at a local point, right? These are equipments which are very heavy, but now it has become very slightly less heavy and you can carry it to the drone, right? So why you want to use a gravity? So suppose you can measure local gravity, right, and local magnetism, right? Where do you think it will be very useful? Anyone? Yes, mining applications. Like what in mining applications? Earthquakes. Correct. So what exactly, right? So, sorry? Perfect. That's a good idea. Good one. right? One very interesting thing what people do is the fact that other than geological mapping is to figure out minerals. Some certain minerals have higher density than some other minerals, right? Especially if you have a magnetometer, we have a meter and a magnetometer. Iron, if you want to detect iron ore, right? You basically, when you fly, you will be able to find out, you can pick up, magnetic and gravitational effects, right? Because of different densities which are present, right? So very, very fast and very, very cheap way to actually, prospect for large mining, right? Yeah. Yes, you can, right? Because essentially wherever you are getting, gravitational signatures, you will have different effects. Mostly people use this today for, the most obvious thing is everybody wants to make money, right? So they will want to fly it on top of, large areas to figure out where minerals are, and that's a huge business. Very unfortunately, all of what I'm saying is done by Australian firms in India today, right? So very unfortunately, nobody is doing, there's no Indian firm doing all of this. There's a lot of money we are spending, we are actually giving Australians, right? Other than that, I'm going to very quickly skip this. This is basically, another, type of a sensor, which is a passive micromillimeter wave, right? So this is basically used for all soil and irrigation mapping and whatever. Very similar to hyperspectral, right? And very similar to, multispectral imaging, right? So I think you guys got a context. I don't want to, keep you guys waiting for lunch, right? So this is the last thing I'm going to talk about, right? So why everybody is using drones today, right? People are using drones because it's extremely less carbon footprint. It is very economical compared to whatever people are talking about. And one important thing what people don't talk about a lot is because it becomes more, once you fly a drone, you automatically collect digital data. It's automatically repository. It's automatically on some software, right? It is not something which people really need to, analyze, really need to sieve through a lot of data, clean data, all that, right? So those are things which are possible using drones, right? So I will not keep you, too much in front within lunch. After lunch, I will quickly, talk to you about, some level of all the software of these applications. I will show you, how all of these, thermal data sets, how everything actually works, right? Thank you for listening. Have a great lunch. See you again in whatever time these guys tell me to come. Sorry. Okay. President without. Even I'm not sure. Not really an expert in this.
It's this button. Here.
Okay.
Hello. Very good afternoon. ಈಗ ಎಲ್ಲರೂ ಊಟಾಗಿರೋದು ಗೊತ್ತಾಯ್ತು. So now we have post lunch session with M.T. Ramaswamy again. He will be speaking on
Yes, I'll be speaking
payload,
on
drone data analytics. After that, we'll be having one more session and then valedictory, where you will be given certificates. Okay. Then after valedictory, there will be a high tea. After that, you can disperse or you can stay here. Okay. Yeah. I welcome once again M.T. Ramaswamy, CEO and co-founder of Skylark Drones. Thank you for accepting our invitation in a short period of notice. Thank you, and over to you. Hello.
Okay, cool. Cool. You can start. Hello. Can you hear now? Hello. 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 It's okay. I can talk loudly, no problem. Hello. It's okay. Fine. Huh? That's that. Okay. Fine. Great. Okay. I'm going to take a little bit time. Okay. Great. First of all, thanks a lot for coming back after lunch. Right. So I'm going to very quickly, the topic what I've signed up for, and I guess everybody is interested to know. is on drone data analytics. Right, I'm not going to, I think the first time I showed you some extremely boring presentation, so I'm trying to make it a little bit more interesting. Fortunately, I don't have any drones to show things, but I'm going to make it a little bit more interesting by showing you some softwares. Right? So I'm going to show you in brief, two softwares. One typically on how to control drones, right, in general, and whatever we use. And second is software around application processing, image data, something what I spoke to show you the data set per se. Right, so anyways have a little bit more interactive feeling on what is application, analytics. Right, so the first one is called Ocean Ops. What is our software? What we do is basically for flight and fleet management. Right, so you can possibly use this application. If anybody has an Android phone here, has a drone, you can possibly download the application. It will help you, fly drones. But I can show you some cool stuff. Right, okay. So this, I'm going to very quickly show you about, what are the two things that this can do. One is about, drone data machine planning of sorts. So here, you can basically create, a site, right? So, sorry, I'm going to upload a site. I'm going to create a ROS, right? So, the login again is suppose. Wait a minute. Slightly low connection. Okay. So I'm gonna quickly draw a site, right? So this is how basically, want to do any sort of application. You start it, right? You say I want to fly an area, right? So I say, let's say, say Karnataka Science and Technology, right? So we go here, right? Right? So I say confirm location, right? So you want to map this entire area. So you want to say you want to do a land survey of this region, right? So all we do is basically draw. Just going to draw. I'm going to make it extremely for the sake of time. I'm going to happily do some absolutely random polygon here, right? 690 acres. I say confirm area. KSTA mapping area. Cool. Right? I save a site. I say I want to map this area. So this is typical land survey. I click map, and all of these are pretty standard features. When you talk about GSD of 3.5 centimeters, it's basically the resolution of the data set that we really want to do survey of. Camera model, all the drones which you can possibly do is there. So you can basically say I want typical, say, mapping drones, common drone, DJI drone, right? And I'm not going to go through a lot of drone speed and things like that, but there are things you can play around with. Other than that, I'm just going to say save mission. So what happens is the fact that this is how to create, a site for surveying, right? So once you do that, you will get your flight, right? So look at now, okay, there's 422 acres. I think the other one was about 290 acres, right? So you can possibly, if you have a mobile phone, Android phone, and you have your own, drone or sorts, you can download this application. You can fly even now, right? And it will automatically fly. It will collect some images. So it will collect around 670 images plus 45, so about 1,500 images for about 690 acres of land, right? It will take about 2 hours to fly. So that's all it takes to cover 690, 700 acres, right, of area. Extremely quick compared to if you are going to survey about 690 acres, right, without this. So once you do that, I'll show you the application where it's used for processing the data. So I'll give you it's a very simple application. I'll show you that what you can do to drone data, right? But other than that, this software is also used for going live, right? So I have a video on that because I don't have any drones. It says don't hide drone skills. So you can't teach on somebody who's already doing it. So I'm going to show you quick video on what happens, right? What are the other applications if possible, right? Sorry, I'm showing a lot of what we have built already, but I don't have any material to show, right? So this is something what we call having a drone video call, right? So what it basically means is the fact that you have a drone and you are, flying the drone and you want to, call someone to show the live feed of sorts. So what happens is you can initiate a drone video call. So this is what you will see on your, mostly on your PC, right? On your phone, right? And there is somebody sitting remotely, somewhere else in the world, right? He can see exactly what you see, right? On the video, and he can also talk to the pilot. Both of you can have a live conversation, right? You can say fly closer, you can say fly further, right? I don't know whether this has video. Oh, sorry, it has something, right? Sorry for the random music, but what is possible is, yeah. So he can, a remote person can actually talk, right? So what it means is, I'll shut the video so that I can talk, right? So what it means is the fact that if you are flying anywhere, this HSR remote to our offices. So anyway, so you can, we also build some algorithms where you can real time, anybody can do this, can real time detect all these stars or whatever, bikes, people, whatever, right? So you can automatically detect on the live video stream all of these things. So what it means is the fact that for all intrusion detection, security surveillance, something which we spoke about just before lunch, is all possible extremely quickly using this application, right? So especially for any sort of disaster management, if people are standard somewhere in Chennai or anywhere else, right? And they need real-time assistance. This is extremely quick to detect and do this. And this is something anybody can do, but essentially this is a drone video that we can get, right? So this is on security, but I'm going to very quickly show you the other applications, right? So you guys remember we did some mapping, right? So I am going to very quickly show you how. So it's simple though, you just license the software and buy the drone and you can do it yourself. You don't need us. Yeah, we have partners, we have some pilots, you can send them to you, but yeah, that we do, but essentially we don't like doing it. we like sending the entire software and being very happy, but sometimes our customers want us to do it, which we end up doing. Right, so anyway, so very quickly I'm going to show you some of the other whatever mapping applications. Go, let's see, right, so we go to, this is an urban mapping area, very quickly we're going to show you that, what it looks like, right, so, yeah. So this is an exactly 2D map, right, of what I had showed you. Once you do that, collecting some images, this is what you will basically get, right, in terms of accuracy, right? As you can see, I can go extremely close, and as I promised earlier, I can measure the seizures, right? I can say how much is this, and it will tell me 0.54 meters. I can convert it, but essentially that, right? I can do a whole bunch of other things also, other than measuring, stalking on people. I can very quickly, this is a rooftop, right? I have a bunch of things here to show you. This is the area of roof, this is the perimeter of any rooftop. Very accurate, 3 centimeters plus, right? So that is on that. I can also, so the interesting part is I can do all of this, we have built some AI, I can show you, anybody can do this, but I'll show you what it is, right? So you can do, say, building detection, you can do vegetation detection, you can do tree count. So I'm just very quickly going to show you, just a building, just say run on this also, I say confirm, right, because whatever, right, and I will, for the sake of very quickness, I will show you how it looks. detection looks on this area, right? So these are all the buildings which are there, right? Automatically mapped, right? So yeah, I'll show you. Yeah. I'll show you that, but on 2D, right? So these are all 2D. These are all buildings, right, on this area. I can very quickly show you all the vegetation also. These are all the vegetation, right? So you can. So I'll show you one interesting application, right? So what is the most interesting application on this is the fact that if you had, electricity lights, and mostly what happens is the fact that electricity lights in India, unfortunately, all of them have to be covered, right? Most of them, right? Which is exactly the same thing here, right? Because if there is wind touching or like a Chennai flood happens, right, and tree will fall on the electricity line, your entire area is, you have to shut down the entire network, right? So challenge really becomes in all of these cases, we don't like to have tree, but we know where the electricity lines are, right? But we do not know how many trees whether they are covering or not, right? A very large area. So if you run some of these models and run some urban mapping, you can potentially see that. You can see here, right? So you can see, okay, there's a tree cover over here, there's electricity line going right next to it. Ideally, you are supposed to prune the tree so that you don't interfere with the electricity, right? So that is something which is possible, right? Now, very quickly to go to this on 2D. I will show you something on 3D as well, right? Yes. Okay. Mines are great, elevation. This I'm going to very quickly show you what is possible in mines, right? So once you fly a drone on a mine, you will basically get this kind of data, right? Again, extremely accurate. You can keep going as less as possible. Just going to scroll up and show you in 3D, right? This entire thing is in 3D, right? And as you can see, this is text. Mostly in most miners, this thing they would have never seen their mine in this great detail before, right? It's almost impossible for them to get this other than drone map. Right? So what it basically means is the fact that for most mining companies as well as other people who are interested, including government, everybody, is the fact that you can now figure out what is the safety hazards of any mine, right? Possible, right? So what it means, I'll show you simple, thing, right? So this is basically a hall in a mine that is where the lorry is actually. So the lorry goes on board, they pick up everything and then they go and so when you're going lorries of that level, you are supposed to have some level of clearance over here, right? So you are supposed to say that this whatever can you see this is one, this is supposed to be there, right? Because you don't lorry doesn't tip over. But as you can see, there are multiple places where it can, right? So this is actually a safety value, right? If I run an elevation profile on this, I will know exactly, how much is is it as per mandate, not as per mandate, etc. Right? So for example, this is the elevation profile, right? So if I go here, I will exactly know, okay, this is our height over, this is just, literally little less than 1 meter on top, right? And there is steep slope at the bottom, right? So all of these kind of violations or whatever might be can potentially be avoided, right? If you have good amount of drone map, right? You can very easily see, right? And you can run this across the entire model, but that is basically what is possible, right? Other than this, I'll tell you some very simple stuff that we do for all our customers. Like we basically tell people how much is the content fail, right? How much are they cut? Let me go back to me. Go on, please. Yes, right? I can show you. Give me a minute. Yeah, so I can quickly, show you how much is the volume excavated, right? So if I had to go here and I click this particular polygon, right? Because it's easier, right? I know cut fill, and I can say the entire volume, right? I can show you how much is the volume. So they have cut in this red region. And they have filled in these blue regions, right? So they basically taken some material, right? And I can run it in different places. I can actually show you, other places. It's very easy to compute this, right? Because we have the entire method and this. So for example, if I want to say how much is the thing over here, I have to draw a polygon, right? Suppose I want to know how much is this, right? How much have they excavated? Have they excavated at all? So I just say elements, right? I click, right? And I can happily, okay, so sorry, right? So not able to do that. That's okay. I don't have access to compute volume, so we have some access issues. But yeah, I'm going to show that volume, right? I say select surface, I say medium, I say calculate, and it will automatically calculate the volume of this polygon, right? It will tell you how much is it. We can tell how much is the net volume, right? That's 1,000 odd meter cube of cut, which has happened. So people have excavated around 1,000 meter cube. They have missing. Good question, right? So this is with respect to so we have different surfaces, right? We are calculating it with respect to DTM, right? We are giving a tolerance, and what we are doing exactly is the fact that you can potentially have different surfaces of the children. You can either interpolate it with respect to the corners of the district, or with respect to the previous survey, right? Or with respect to a reference, right? So you can have 3 different layers of computing this volume. This particular thing is basically interpolated with respect to these, like car irrigation, right? But basically we use that. But we have multiple, different surfaces where you can compute the volume. Need not be one, right? So you can see volume comparison or volume. You can see a volume comparison, volume from a reference area. You can do that reference value. You can say that, okay, I want to respect to some, I don't have this entire thing with me, but I can very easily, compute it with respect to different, this is the highest point, this is the lowest point, if I say 520, right? I can easily compute with respect to this particular reference value. That basically means with respect to this 520 meters, this is all of this is a fill, not a cut of sorts. Right? But you can do whatever you want with respect to volume and with some reference plane, volume comparison. I want to find that this thing, I have to go here and see what is the elevation point. This is the elevation of that point, 546 thing. I have to possibly go back. This is latitude, right? So I can go back and do the same thing. Sorry. You can do it with this, you can do it with the same software, but you got whatever I need to do, right? So anyway, so cool. So this is respect to 3D, right? You can do slope maps, you can do contours. I'm not going to go into all details because you guys know what is possible, right? So this is what potentially you can do with, with respect to just RGB. I'm going to very quickly, show you the last thing I'm going to show you. I'm not going to take too much of your time is thermal, because we spoke about that as well, right? So this is a typical solar plant with some thermal, how this is how it looks when you actually map the entire solar park with respect to just, thermal map, right? We have a thermal mosaic of sorts. What you can do here is the point that you can go at different point and it will tell you the point temperatures, right? I don't have that thing with me right now, but you can do that. Okay. Interesting. I don't have it with me, but anyway, the thing is not loaded yet. But anyway, but you get the idea of this. There's no thermal. Okay. So anyway, so I think we have deleted that file, but I think you guys have an idea. Sorry for that. I'll show you some other projects that I have something like this. Videography. Solar pre-construction. Okay. I don't have. No, we are not part of the mining project. Yes, is not yet part of it, right? Not yet. Okay, interesting. Yes, so other than that, I want to very quickly show you last piece of information since I didn't do that. I'll give you a quick, demonstration of, how we do, survey, right? So what happens, right? Typically, once you upload a data, right? This is how our process pipeline actually looks, right? So it's very simple. You have to upload the data. You have to upload, like after you do mapping, you have to upload image data set, and then you basically, very quickly, I'm just going to browse some images. Okay, it's not yet downloaded. Okay, shit. Give me a minute. I'm going to show you. Downloads. Okay, got cancelled. Great. I can't show you that. But anyway, so net what I'm gonna tell you is the fact that if you have any images from any sort of survey, there is no data, right? This is all survey data images. For people who don't know this, once you do the mapping, this is how you will collect images, right? So you collect it at some overlap, right? So these are all the images which you collect in drones, right? It's a very simple, image data set which you upload to any photo. Not necessarily, there are a bunch of companies you can, Google them, just 40 bunch of them, right? You don't need to work with us, but essentially everybody works in a very similar manner. You upload image data here, right? And then you take those images and upload it. Once you upload it, you get, this is basically what you have, right? Some amount of images, 54 images and some 450. And basically you say you can process this data, right? You just say initial processing, final processing, etc. You say confirm, and you just say process data, whatever. You just say process, and then it will basically process this data, right? Once you process this data, you will get that map. It's kind of starting the process right now, but ideally what I mentioned is the fact that you will get a map like this, right? This is a map that you generate, right? And you'll have all your routes, whatever I showed before. It's quite extremely straightforward. Anybody can do it. It is not hard, right? That's what I want to leave you guys with, right? If you guys buy a drone, you can map. Within the first 5 hours of you flying the drone, you can map the canvas. Okay, so not all difficult. Anybody can do it, and you can start measuring the entire things, right? You can do a whole bunch of other things. You have a thermal camera and thermal drone. You can do the same thing with thermal alarm, like I mentioned, right? Extremely straightforward. Hence, a lot of people have started doing drones. You can see the next, at least 2-3 years, there will be a lot of people flying drones for various applications, right? So that is what I want to leave you with, right? I don't know how much time I spoke, but I want to take more questions now, but that is mostly what I had for today, right? Yeah, please. You can, like, vertical assessment as in, I didn't understand the question. Got it. So simple. So when you do a proper mapping, typically what the drones what you use will be RTK enabled, right? It will not be RTK enabled. And number 2 is you can put a ground control point. A ground control points are points where you want to put, say a survey point, which you should collect information to some DGPS or some permanent benchmark, right? You go put a permanent benchmark or a ground control point over there, right? And you measure it using a DGPS equipment, right? And during this processing, as you could have seen here, data processing, there are some images and there are some ground control points, which you also use to process. Right? So you typically use a lot of ground control points. These are just points and blue dots over here. That is what you use to actually process to get an accurate map. So if you want to assess the same accuracy, you go back to the ground control point and then do your local station survey or any other manual element to actually verify whether the output is correct or not. You can take a reprocess. You have to reprocess, you can take another drone control point, right? Because most of the errors due to photogrammetric processing, there are multiple reasons for it. Either the drone control point calculated may be wrong, because the GPS equipment that day was cloudy and the GPS equipment didn't work properly, right? So you have to put drone control points again, maybe, right? That is one source of error. Mostly photogrammetry source of error is dependent on what the input is. Maybe the images itself was not so sharp, right? So the stitching errors happen, right? Or your point cloud is very dirty. You have to clean the point cloud manually, right? You can do all of these things. But photogrammetry as a technique is not new. It's been there for 50 years, right? So essentially, as long as your input data is proper, your output data will always be right. There are always, any technique you need to figure out what the least count is, right? Photogrammetry has a least count of around 3 to 5 centimeters in XY and 5 to 10 centimeters in Z. As long as your tolerance is around less than 10 centimeters, you are fine, right? You will not get more. If you are doing, you will be having to blatantly mistakes for it to be like 1 meter plus, right? Like GCP being wrong or something, right? If it's around 10 centimeters, you have done a fairly good job, right? That's the tolerance. If you want anything less than that in Z, you would have to go to LIDAR, right? LIDAR will give you that 120 meters of tolerance. All of this is just photography. This is just images. For most applications, 5 centimeters, 3 centimeters are okay. Because I tell you why also, because that is the wall length. If you go to any property and measure the wall, right, that will basically be around this centimeter. So anything around this thing, people are okay with. That's all. Right? So that is basically about that. Right? But that's the tolerance. Any other questions? They're not road. Water you can't. Water you can't use. Most of these sensors are not really capable of water. Right? Dam measurements and everything you can't do using water. You need proper parameters where you go with the water. Sonar you can't use any light based. It will refract and go off. Okay, so you can't use the water. None of these are water actually. Water is there, you can't do anything else. Any questions? Yeah. Ideally, we like the software, but current drone ecosystem, we do a lot of services for our customers because they don't want to buy drones typically. At least not right? Very few customers actually buy drones. Kalpat is a customer we have working with, they bought our software, but otherwise we have a network of pilots who are actually using that. Right? But ideal customer profiles across the world are typically two categories, either enterprises, large enterprises, Tata, all these government, all these people, right? And service providers, right? Who serve them, right? There are a whole bunch of small service providers who have customers themselves, right? They want software to process data, to deliver to the customers, etc. In India today, the biggest challenge is none of them. Very unfortunately in India, what is happening is the fact that we are, importing a lot of drones from China and importing a lot of software from US. Right? So, and we are doing only service in India. Right? That is the reality. Right? So, at least we couldn't compete too much on drones because manufacturing is not there. So, we are building software so that at least we can compete with US customers, which we can. At least that is possible. At least that much talent we have in India to build software. Right? And I strongly encourage you to build software because it's possible we can do. That's, I hope I answered the question. Correct. We have also so Bangalore, outskirts of Bangalore is possible. So these are software. So these are Bangalore. This is yellow zone, right? right? So can use this software to fly drone, right? So we typically fly around squads here. You can't fly mostly in this, all of these are red zone. Unfortunately, these are red zones. Yeah. You can't fly mostly in cities. Hence, most of our customers are also not in cities. We work with mines, and typical drone usage also is mostly mines. Mines, agriculture, solar plants, electricity, power stations. All of them are not in cities. Right? So majority of use cases are in cities. What use cases are around if you want to fly drones from like a rooftop or your delivery use cases, right? Which is some time to go. So till that time there is mostly around yellow and red. So typically what you can't fly much here. And here on wherever we are, right? So this is also very common. Yeah, this is very rare. Right? Against Karnataka Science and Technology. So this is exactly it. And technically right, so that's the challenge. Special types of drones you can land. Other drones are seen for me, but most drones whatever you have in the market is seen without plastic ring. LiDAR will not help, so you need some typical lecture mentioned you have to, you want to sonar and whatever it is, right? It's better. There's a company, ITP Trust which is doing underwater drones, right? They're doing for good friends of ours. They do it for dam inspection, and so we can monitor, but it's underwater, right? It goes underwater and does the entire activity. That's how we do it. Any other questions? Yep. Bathymetry. Can't hear you. No, gravimetry we have not done. We don't have a gravimeter. But I know companies which are doing it, like mostly Australian companies. There's no Indian company which is doing that. There is an Australian company which has a flying plane and they are making a bigger drone and they're doing that one. Yeah. Any other questions? You can build a software for any application, right? You can have today we have images and thermal. You can upload because all these data at the end of the day are either images which are JPEG or whatever else, or point clouds, right? LiDARs are all point data, right? So you can upload anything on a geospatial software. It's not a problem. At the end of the day, you are just either collecting images, point cloud, or something. So all the file formats are more or less dropped. Right, so there's not too much of you can upload objects. You can do a whole bunch of things because there's not much difference in the file formats. Any other questions? Unfortunately, we built it, sir. Very unfortunate, but that's what we did. We took a lot of money from investors and built it. I wish we could do it also, but hopefully we will. But that's free version. We have it on the website. You already use it, no problem. You can we have kept it on the website, so you can use it, no problem. Any other questions, guys? Cool. So, thank you for the time. I am always available and I can give you my number if you want, but you can visit skylab.com whenever you want, and I'm always available in the office, right? my number, right? So this is my number. This is there? Okay, I didn't see that, but anyway, I know that, but this is my details, right? So people can contact me anytime. Happy to help you guys with whatever I can. Great. See you. Depends on how many times you're operating it, but typically it can go up to 2 hours. So, I mean, 2 years, sorry, not 2 hours. 2 years it can go up to 2 years, 3 years. We have drones which have 4 years. Typically, 2 things. It's a mechanical device which rotates, right? If something goes wrong with the battery, right? You keep replacing the battery and you don't fly it too often, it will go about 3-4 years or so, right? It's not very important too much. Can it be upgraded? Not really. You can upgrade software as usual. Like you have an iPhone software, you keep upgrading software. But and you can upgrade the software with your software. But hardware is not. Hardware is not. Any other questions? Cool. Thank you. Thank you.
One more person. Thank you, Gilanji. So we will continue this another session. Afterwards, we will have valedictory and we will wind up. So we will give tea break that time only, IT. So that's what. Please have patience. Thank you, Mugilanji, for your interesting talk. Yeah.
So, very good evening. We'll be starting the last session of our this workshop. Now we have with us Shri Harsha Venkatesh, CEO of Unmanned and Airborne Solutions. Before starting today's session, I would like to give a brief introduction about Shri Harsha Venkatesh. He has finished his education in STM Institute of Management and Development and University of Vishweshwaraya College of Engineering, Mechanical Engineering, and he has a work experience in Unmanned and Airborne Solutions Private Limited as a CEO from 2019 to till date. And before that, he led the operations team in manufacturing operations encompassing production planning, incoming quality, supply chain management, and new product management development, vendor selection, quality management, and vendor development in ICOM Engineering India Private Limited as a DGM operations. And apart from that, Sir has served as Bharat Electronics as a deputy engineer from 2009 to 2012. Apart from that, he was a part of 5-member delegation from India to Germany under the Indo-German Manager Training Program in 2015 and was awarded for an enterprising concept in Big Future 13 and Entrepreneurship Challenge. He is a manufacturing industry professional with experience in business operations, and areas of special focus includes a new product development, design for manufacturing, supply chain management, vendor quality assessment and vendor development, and key account management. With this brief introduction, I would like to welcome Shri Harsha Venkatesh on behalf of KSTA and on behalf of all the participants. Welcome you, sir. Thank you for accepting our invitation to deliver this.
Good afternoon, everyone. So, I think Umesh gave a brief background from where I come. I'm basically a mechanical engineer. So now, by virtue of my profession, I have come into the unmanned aerial sector. Since 2009, I have been working with Bharat Electronics and other entities wherein we have been concentrating on unmanned vehicles. I think they requested me to have one session on the effects of weather and meteorology in UAS operations. So how does weather and meteorology, what is weather, what is meteorology, all those things. I think most of you being, I think, from a technical background are already aware of this. So in the previous sessions, so what all have you gone through? Have you already gone through how a UAS works? So you have understood. So everyone are quite aware of the Bernoulli's principle. So you know how Bernoulli's principle. So let us remember Bernoulli's principle, because a lot of that application is actually required to understand how weather and meteorology affects your UAS performance. So in this session, what I will be covering is basically what is the standard atmosphere, then how do we measure air pressure, or what is the measurement of air pressure, then temperature, humidity, clouds, how does clouds affect the performance of your unmanned aircraft system, then icing, what is the effect of icing, how icing affects performance, then how does a UAS pilot know what is the weather, or what is, how does he know whether he can fly his aircraft or not. So that comes from something called as a terminal aerodrome forecast, or a METAR, which is a meteorological aerodrome report. Then what are the hazardous weather, and how does it affect UAS operations. So what weather elements affect your aircraft operations? So any aircraft when it is flying is affected by the weather, it is affected by number of parameters of your atmosphere. So the first one, the most important, is your pressure. Air pressure, like I told, if you remember Bernoulli's principle, your whole lift of an aircraft is a consequence of the air pressure and the speed. So the most important thing, first one is the pressure, then the temperature. So with pressure varies with temperature and vice versa. So if you all remember our Pascal's law, sorry, not Pascal's law, or Boyle's and Charles' law, then you will understand that how pressure and temperature are related. Then wind. So your Bernoulli's principle again talks about pressure. It also talks pressure with respect to your velocity of air, correct? So what does Bernoulli's principle tell? They are inversely proportional. Higher the velocity of air, lower is the pressure, or higher the velocity of a fluid, lower the pressure, correct? So wind means increased air speeds. So increased air velocity affects your pressure. Humidity. So again, when you have a humid climate, there is again an effect on pressure. There is also an effect in terms of drag. There is a lot of effect which plays on the aircraft. Apart from pressure, humidity is also moisture content in the air. So that also will affect your aircraft performance. Then clouds. So clouds are a very clear indicator. Most of the time, if you have flown an aircraft or you have been flying in an aircraft, you will understand when there are clouds, you experience a different phenomenon. So clouds affect any aircraft operations. Then visibility. So how far can you see your aircraft? So all these parameters of your weather are affecting your aircraft performance. So when you look at an aircraft or an unmanned aircraft, in this case we are talking about an unmanned aircraft. So what is it dependent on? What is its flight dependent on? The first and foremost thing is the all-up weight of the aircraft, correct? So your aircraft the amount of distance that your aircraft can travel or the height that it can fly, everything is dependent on the all-up weight of the aircraft, correct? The second thing is, based on your weight, your aircraft's wings or its propeller must create a lift. So the lift produced by your propellers and your wings are also important for your flight. The third one is the drag created on the aircraft. So the motion of the aircraft is detrimental if there is a large drag, correct? So drag is going to impact your motion of the aircraft. Then your thrust produced by the power plant. So it could be a motor, like in most of your quadcopters or your rotary aircraft, you will see that there is a electric motor. So the electric motor is going to produce a thrust through the propeller. If it's an engine, if it's an IC engine, then again, how does your IC engine, what is the amount of thrust what is the amount of power that your engine can give, also affects your flight. I told the three important factors in the previous slide: pressure, temperature and wind. So this pressure, temperature and wind are going to affect the operations, your flight operations, and it will have a direct impact on your takeoff weight, the fuel requirement or your battery capacity, and the flying time. So basically what we are trying to tell, if any of your three conditions, pressure, temperature and wind, are not conducive for flight, then your takeoff weight cannot be the same as you determined. Your fuel requirement might go up and your flying time might come down if it is not conducive. If it is very conducive, then you can have a better takeoff weight, you can have a lesser fuel requirement, and you can have a higher flying time. Basically, pressure, temperature and wind is going to directly impact all these three factors. So let us understand the Earth's atmosphere. So I am sure that most of you would have already gone through. So the atmosphere is divided into various segments, correct? So there are troposphere, there is a troposphere, the stratosphere, mesosphere, thermosphere, the exosphere. Most of the weather phenomena occurs only in the troposphere. So which is from the ground level, that is the mean sea level, to approximately about 12 kilometers above the ground. So that is about roughly 40,000 feet. So up to 40,000 feet is your troposphere. Above which is the stratosphere, the mesosphere and thermosphere, exosphere, which actually is not really consequential for UAV operations. What is standard atmosphere? There is something called as a standard atmosphere, and the standard atmosphere is basically a unit of air pressure, of the atmospheric pressure. So it is a unit. Let us remember, it is a unit of air pressure, the standard atmosphere. So it is defined, or the value of standard atmosphere in terms of your normal units is, you can see here, it is 101,325 pascals, or it could be, it is also told as 1.01325 bar. And most of your agencies which give you, or in most of our aviation discipline, always the pressure is expressed as hectopascals. You can see here, it is hectopascals. So it will always be given as HPA. So 1 HPA is 100 pascals. Okay. So basically, how this standard atmosphere value has been derived. So this is the average atmospheric pressure exerted by the Earth's atmosphere on a body at mean sea level. So here, if you remember Pascal's law, what does Pascal law tell? The pressure acting on a body is uniform. So similarly, atmospheric pressure is uniform at that level. At your mean sea level, the value is 1.01325 bar or 101,325 pascals. So when we speak in hectopascals, your standard atmosphere is 1013.25 hectopascals. So most of your weather reports, the METAR, what we see as we go forward, TAF, everything, will always give the pressure in hectopascals. So how does atmospheric pressure act in aircraft operations? What happens to air pressure when you increase in altitude? Sorry? It decreases. So the air pressure with respect to increase in altitude always reduces. Correct? That is the first point. Then a reduction in atmospheric pressure has an effect on aircraft performance. I told you that aircraft performance is going to get affected. So how does it get affected? The first thing is, when the pressure is lesser, the difference of pressure also becomes lesser. The lift produced by your aerofoil changes. It reduces. Second thing, the thrust produced by your propeller, because you are operating in a low pressure environment, the thrust produced by your propeller also drops. That means if your propeller had to produce a thrust of say 25 kgs, it has to do more work to produce the same thrust. So that means it has to spin your rotor or spin your propeller faster. If it has to spin your propeller faster, it uses more current. So if it is using more current, your battery consumption increases. So your total endurance drops. So with increase in altitude, your thrust generation required is higher, your battery consumption decreases. And also, but reduced air pressure also has an advantage. What is the advantage? It also reduces drag, because the number of particles available to create a resistance for the motion of your aircraft has reduced. Now there are less resisting particles. So basically your reduced air pressure also reduces your drag. So the international standard atmosphere. So as a whole in the world, so if India declares some standard atmosphere, if Americans declare something else, it becomes a difficulty. So there is something called as an international standard atmosphere, which has been really recognized, and they provide a chart which actually tells how your pressure, air pressure, varies with respect to altitude. So you can see on the left side, this is the ISA, it's very simple, similar to the ISA chart. So it tells how much pressure, at what altitude, what pressure you can experience. So this chart is available generally. So this is actually referred basically by all the aviation people to ensure that they are operating at the proper altitude. So the effect of temperature on UAS operations, on aircraft operations. So I told pressure is also a function of temperature, correct? But in the atmosphere something works. As you ascend in the altitude, there is a drop in temperature, correct? Lower the pressure, the temperature is also lower. This happens because there are number of factors which are affecting temperature. The number of particles available as we increase in altitude, you would have heard, if someone did mountain climbing, when you go up a mountain, it is called rarefied air. That means there are lesser air particles per cubic area, correct? So lesser air particles means less number of molecules are colliding with each other. The temperature is also lesser. So there is something called as a temperature gradient. So we call it as the Laps rate. So your temperature, you can see here, your temperature actually reduces by 2 degrees centigrade for every 1000 feet increase in altitude. So temperature reduces by 2 degrees centigrade for every 1000 feet, or it reduces by about 6.5 degrees centigrade for every 1 kilometer of increase in altitude. So you can understand why Bangalore is cooler than Chennai. So Bangalore we are standing at 900 meters. So that means we are already 6.5 degrees cooler than Chennai. So sea level to Bangalore temperature, sea level to the higher temperature or higher altitude, the temperature is lower. So we can see here the second point, the temperature generally decreases. So on the other consequence, what we should have seen, if there is a lower pressure in an open condition, the temperature should have been higher, but here temperature is still lower. Okay. The decrease in temperature at altitude also contributes to the decrease in pressure. So if I am going higher, I am also experiencing lesser pressure. So or vice versa, lesser pressure was creating lesser temperature. Correct? So both of this is going to affect your aircraft performance. Humidity. How does humidity affect your aircraft? The first point that you have to remember is humid air is less denser than normal air. Your dry air is more dense than humid air because your moisture replaces nitrogen and oxygen in the atmosphere, correct? Basically, what is humidity? It is the availability of moisture in your air, correct? So once moisture replaces nitrogen, that means your density of air is coming down. So less denser the air, you have to create more work to create the same thrust, correct? Humid air will not create the same thrust as your aircraft has been designed. So reduced air density affects your aerodynamics as well. So when we reduce the density of air, basically again affecting on the pressure and other factors, what is going to happen? The aerodynamics of flight is going to get affected. Then high humidity conditions. So this is more commonly observed in coastal areas where the humidity is much higher. There is something called as condensation. You would have all seen condensation. The most common condensation example we always give is in trucks. Trucks earlier or even today have pneumatic brakes, correct? In coastal areas, this pneumatic brake, if the driver forgot to remove water from his system, we call it as a condensation system. If he forgot, the effectiveness of the brakes come down. So, lot of lorry accidents used to earlier happen because the driver would forget to empty his filter. So, if he did not clear his filter, that means there is more humidity inside and it has condensed. So, and water is an incompressible fluid. So, when incompressible fluid went inside your cylinder, that means the effectiveness of the brake came down. Similarly, condensation also happens in aircraft. And when condensation happens, the biggest problem is it can short circuit your electronics. It can affect your batteries. Most of your electronics can get into problems. The second problem of condensation is corrosion. In coastal areas, corrosion happens on your parts. Most of your aircraft will have fasteners. So fasteners are your primary, or something which is holding your primary structural elements. So when someone has explained to you about UAVs, you would have explained about what is a primary structural element. So the primary structural elements, your wings or propellers or arms, the chassis, everything is held together by fasteners which are made out of steel. or made out of MS, whatever it is. So these can corrode, and corrosion can lead to catastrophic failures. And in an aircraft, what are the, or your unmanned aircraft, what are the most three common sensors which are used? Barometer, correct? Accelerometer and gyroscope, or your compass, gyroscope or compass, whatever it is. Okay? So these are the most three common sensors. What does a barometer measure? It measures atmospheric pressure. So when humid air is less, dense, pressure can also be lower, but your altitude above the ground is also determined by your barometer. But your barometer, if it is not calibrated, what is it doing? It is now reading a higher altitude or a wrong altitude, correct? In humid air, it will read a higher altitude. But if you were to have set your operation, say at very close to ground, say about 2 meters, and your barometer is already reading a wrong reading, there are all chances that your aircraft can crash. So humidity or moist air can create issues with your sensors also. So corrosion I already explained. So the other thing, what you also have to remember, why we must look at humidity is, so an increased humidity is always also correlated with other weather phenomena. What are the other weather phenomena? Whenever your meteorological department is actually giving you a report, they tell there is a high chance of rain. They are predicting a high chance of rain because they would have seen that the humidity is going up considerably. You would have observed if you are on the outside and you feel that you are sweating more, that is the humidity is more, then there is a very large chance that it could rain in the evening. Have you all experienced this? So this is the most common thing. So higher humidity can also be meaning that there is an associated weather phenomenon. That means it could be could be fog, there could be mist, or there could be rain. Then effect of cloud on aircraft operations. The most important thing in any aircraft operations for cloud is it reduces visibility, correct? So once there is a cloud, the visibility of your aircraft comes down because cloud is actually obstructing your view of the aircraft. The second problem with cloud is most of your unmanned aircraft are operating using GPS signals, correct? They are using GPS signals or navigation signals to continue their flight, perfect? But cloud can create an issue in terms of the reception of a GPS signal. So what we observe when we are flying an aircraft, we generally think or we tell that minimum number of satellites connected to an aircraft should be about 15. So that means I will get a HVOP of less than 0.7. So there are a number of factors we use. But when there are clouds, we also observe that when there are thick clouds, there are different kinds of clouds as well, cirrus, cumulus, all those things. So if there is a cirrus plus cumulus, cirrocumulus cloud, then the biggest problem is that your satellite signal itself is already attenuated. That means your reception on your GPS receiver is already wrong. Okay, so this is going to affect precision operations. If you are doing a precision operation, it is going to affect presence of cloud. So this is the third point that I mentioned. UAVs heavily rely on GPS for positioning and navigation, and your reduced signal quality is going to affect it. Then most of the regulations, in India it is very common. As per your drone rules 2021, you must always have a visual line of sight. You can operate your aircraft only under visual line of sight conditions. So your cloud will reduce your visibility. So that means your range of your operation will reduce considerably. So you must always consider how you are going to operate it. The next thing is, in agricultural operations, say for example, we do something called as hyperspectral imaging, multispectral imaging. So here the most important thing in terms of your imaging is the incidence of light. So incidence of light in this case is sunlight, and cloud obstructs sunlight. So if you are going to do a operation, multispectral imaging operation, when there is a cloud, then there is going to be an error in the data that you capture. Why is that? what are we doing in the multispectral operations? You are impinging light onto an object under observation, and then you are taking back the impinged light, and you are calculating in what wavelength the impinged light has come back. Correct? So that is basically to determine how the health of the crop is. But if your light itself was wrong, that means your impinged light itself was wrong, that means your sensor is already reading a wrong reading. So basically if you don't calibrate your sensor, it can be an issue. The second thing is when there are moving clouds, that means that it's not a continuous cloud, it's not a completely overcast condition. If the clouds are moving, so half of your mission might be under cloud, half under sunlight. Then your calibration also does not work. Even your DLS, we use something called as a downwelling light sensor. The accuracy of that is dropped when we are operating in cloudy conditions. So the same thing, and your remote sensing application. So for example, you are doing a mine survey. The quality of your data gets reduced when you are doing it in cloudy conditions, because again, the availability of light, the exposure of your lens, everything is reduced. So how do we determine how much cloud is actually there? So it is defined as in a unit called as octas, and 8 octa means basically you have a complete overcast condition, and you have to divide your visual range into 8 segments, and based on that you can actually tell what is the cloud coverage. So when you see this, there is no cloud in all your 8 segments, 1, 2, 3, 4, 5, 6, 7, 8. You can see no clouds. So this is a 0/8 octa reading. That means it's a clear sky. So here you can see, if you can, in different segments, say in 2 segments, you see clouds, then that means it's a 2/8 octa. Still, this might be okay to fly your aircraft. So similarly, this is a scattered cloud, 4 of 8. So maybe good for certain operations, may not be good for certain operations. And if you see on all 8 octas, that is 8 out of 8, then it is a overcast condition. So it is not advisable to fly your aircraft when there is a 8 out of 8. Even anything above 6 out of 8 octas is not advisable. You are not advised to fly your aircraft because there is a high chance of rain and a lot of other conditions are being affected. Which one? So no, this we actually use this in the visual range. So whatever you are seeing in terms of, say for example, you stand in your open atmosphere and you divide, say this is your first octa, correct? Then the second, then the third and the fourth, which is on the top. So you just look around to understand. If you divide your visual range in 8 segments, that is how it is calculated. Your meteorological report actually does it using radars. So they use radar to determine how much of your atmosphere is covered or your sky, visible sky is covered. Okay, they use a radar. They don't use visual. So visual is only for basically for the pilot who is on the ground to understand what condition he is operating. Obviously the radar is much better, but why we always tell that the pilot must know where he is flying is, your meteorological report, the METAR report, I will also go through that, is always available only up to 5 statute miles, that is about 8 kilometers from the point where they have observed. Above 8 kilometers there is no guarantee, it could have changed, the weather pattern would have already changed. They look at only about 5 statute miles from the point of observation. So effect of wind, like I told earlier, one of the most important criteria in terms of weather or your atmosphere is your pressure, and winds have a substantial effect on the aircraft performance. Basically, when we look at an aircraft, so we look at 3 types of winds. One is crosswind, which comes from the side of the aircraft, the headwind which comes onto the nose of the aircraft, the tailwind which comes onto the tail of the aircraft. So in a fixed wing operation, headwinds, tailwinds, crosswinds, everything affect a lot. Mostly in your quadcopters, in your rotary aircraft, the effect of wind might not be very high in terms of your takeoff and landing performance, but it can destabilize your aircraft. high winds are going to destabilize your aircraft. When you look at a fixed wing aircraft, how does your wind affect? Generally, when we are taking off, we can take off in a headwind condition or tailwind, which you have gone through the Bernoulli's principle. No? So, what is the recommendation? Can we take off in headwind or can we take off in tailwind? Headwind is opposing, it is opposing the aircraft. Tailwind is pushing the aircraft. Now tell me, when can we take off the aircraft? Whether can we take off in headwind or tailwind? So let us have a call. Headwind, how many? Tailwind? Okay. So it is always a headwind condition. Why headwind? The speed of your aircraft determines the pressure difference also, correct? So higher speed of air, higher is the pressure difference. The aircraft can take off faster. If you are working in a tailwind condition, aircraft requires a longer runway, correct? It can overshoot the runway in tailwind condition. So what is your aircraft doing when it is taking off? It is working against air, correct? It is moving in the direction and it is working against the air, correct? And when there is a headwind, it is also helping it to work against the air. So the speed, the relative speed increases. The pressure difference increases. The pressure difference, that is between your bottom and the top surface, increases. The aircraft takes off faster. So always remember to understand this. When you are operating a fixed wing aircraft, you have to take off in headwind directions only. You cannot take off in tailwind. What if there is a crosswind? What happens when there is a crosswind? It is not affecting your takeoff, but in terms of the lift, it is not affecting. But what is happening is, it is affecting the stability of the aircraft. It is creating a roll on the aircraft, correct? And when we are doing a takeoff, generally we are not giving any other commands apart from the thrust, correct? We are not giving any roll corrections, we are not giving any yaw corrections, we are not giving any other corrections. So crosswind, landing or takeoff and landing is generally avoided in heavy crosswinds. Normal crosswinds, yes, people still take off. So you would have observed many videos on all your Facebook and all. So people, the pilots trying to land an aircraft in a crosswind, they land it in a cross direction. Basically, they are controlling the roll of the aircraft. So flying against a strong headwind can reduce the UAV's ground speed and increase energy consumption. So when you are looking at rotary aircraft, and if there is a strong wind which is opposing your aircraft, that means that drone or your UAV is actually working against your wind. So it will consume more of your battery power. In rotary aircraft, it will consume more of your battery power and it will reduce your speed substantially, it will reduce your range substantially. So always consider when you are working in high winds, this effect must be taken into consideration. So also when you are working in a GPS environment wherein your aircraft is doing an autonomous mode, except for position hold, if there is a wind, your aircraft can get pushed out of its desired point, correct? Because wind is going to push the aircraft and it is not going to have a correction. So all of this is going to get affected. And you will also observe when there is a higher wind, your aircraft tends to drop its altitude. Again, this is because higher wind means lesser pressure. Your motor, the time it takes for your motor to generate that extra thrust is still not there. So your aircraft is going to drop its altitude. So wind affects your aircraft in these things. So like I told, quadcopters again get affected. And also when you are working in close proximity, say for example you are working with an aircraft, say an agricultural spraying. So if you are doing your operation very close by and there is heavy wind, the first thing is there is a lot of drift of your chemical. The second thing is the aircraft itself can come on towards you or it can create problems. So you also have to remember strong winds when operating in very close quarters, you have to take care. And wind limitations in the operational module. So your aircraft manufacturer, the OEM, would already have told that what is the maximum speed of wind that your aircraft can operate at. That has to be considered while operating your aircraft. And fixed wing, like I told, are already affected, especially crosswinds. It can create real problem if you don't give roll corrections. So, apart from flying in open areas, there is another issue that we also have to remember. When flying in urban environments, the wind speeds are different. It is not constant across your ground. You can see here, between two buildings, the air moves across the building. So the wind speed in between the building is generally higher than the ground speed. Okay? So this is one area. So if by mistake when we go around a building and the aircraft comes in between, it is going to get pushed away. Then you can see here, this is actually it is actually creating something like a turbulence. So the wind which came here took a longer path and came over. But here also it took a shorter path. So that means the wind speed here has increased substantially than the size. So if you are flying above a building, then again the wind speed will be higher. So you can see here what is happening. The wind has come, it has increased its speed, and the aircraft which has come gets pushed away from here. The second thing is when the wind speed is higher, what happens is, like I told, pressure drops. Again, Bernoulli's principle. When pressure drops, your aircraft has a tendency to fall down. It reduces its altitude. Until its motor comes back to a higher RPM, it is going to fall down. So these effects have to be taken into consideration. So what is the wind speed gradient? So one is the change in wind velocity with change in altitude. So always remember your wind velocity also changes with your altitude. If your ground wind speed is say approximately about 3 meters per second, at 10 meter altitude it could be 6 meters per second. It can double. So the wind speed is higher when you go higher in altitude. So we need to expect a change in speed from in the column directly above us. So here you can see wind speeds are usually double at a height of 100 meters above ground. The next is icing. So what is icing? The formation of ice crystals on the blades of the propeller or on the wings of an aircraft is called as icing. So icing happens because of two reasons. One is that your air is already at a freezing or just less than freezing condition, and your propellers running create a lower pressure and incidentally a lower temperature, causing a temporary reduction in temperature which freezes the moisture around the propeller, and it results in build-up of ice on the leading edge of the propellers. See, icing occurs when operating in temperatures close to the freezing temperature. Then it also occurs because of when the air passes through the propeller, the reduction in temperature creates icing. But what is the problem? If icing happens, what is our issue? So with icing, drag increases. Your propeller efficiency drops significantly. The weight of your propeller increases. So if the icing is not uniform, the balance of propeller goes bad and your aircraft can have an issue. And icing occurs instantaneously. It is not a phenomenon which is built up. It can happen just in a fraction of a second because of the decrease. Like I told, in a fraction of a second the temperature drops, and instantaneous temperature drop creates the effect of icing. So how do I avoid icing? Try to avoid flying in misty conditions, very cold conditions. So now so you are asking how do we know what is a reliable source for meteorological data? So one of the most reliable source for meteorological data is your terminal aerodrome forecast. So TAF is given by all the aerodromes. So it is given 4 times in a day generally. Most of the civilian airports will declare TAF every 6 hours. Okay, and this is actually covering up to 5 statute miles from the airport. Say for example, if you are in Devanagari or KAL airport, from there approximately about 8 kilometers in radius, this report will be valid. So that is the general consideration. Yes, this is available for public viewers. So you can go online. So there are many websites which publish the data from the airport. So you can access this. So there is a meteorological aerodrome report. So this is also, what is the difference? TAF and METAR, both are mostly the same, but METAR is also used by meteorologists, and also this is more of, also includes a forecast, what can happen in the next 6 hours, kind of a report is a METAR. So a METAR is a standard. All your aviation, your pilots, all your airmen use the same standard. It comes as a standard format. So it will be like this. You can see here below. So this is a METAR report from KAL Airport, that is our Bangalore International Airport, for today. So how do we read this kind of a METAR or a TA? So you can see on the top is VOPL. VOPL is our airport designation. For Bangalore Airport, the designation, the international designation as per ICAO is VOPL. Okay? Then it tells when was this report generated. It is 08, that is the 8th day of the month, that is today, 8th December, this report has been generated, and it was generated at 0630 hours UTC. Always your report will be in UTC. Anything in terms of aviation will always be in UTC for time zones only. So at 6:30 UTC, the report was generated. Then you can see here there is 13006 KT. So the first 3 digits is the direction of your wind. So the first one was your airport designation, then at the time, then is the wind designation. So the first 3 digits will be your direction of the wind. So that wind is coming with the direction of 130 degrees. What is 130 degrees? From north, it is 130 degrees. So the wind is coming from in a southeast direction, correct? 130 degrees is southeast. So it is coming at 130 degrees. Then the speed of the wind is 06 kT, means it is, the wind speed is 6 knots. Then there is something called as 6000. So that means the visibility at that airport is 6 kilometers. There is a clear visibility or line of sight for up to 6 kilometers from the airport. Then there is then the 2 things will be clouds. So it is telling scattered clouds. 012 is 1200 feet, scattered clouds at 1800 feet, scattered clouds at 1200 feet, and scattered clouds at a height of 1800 feet at Bangalore Airport. Then the temperature at that point was 26 degrees centigrade. Then I told the pressure, always the pressure is in hectopascals. You can see 1017. So the pressure was 1017. This is the pressure at the airport. It is the QFE pressure. That is the temperature, lower temperature which can be witnessed in the airport. The higher temperature and the lower temperature. It is not mentioned. Okay. So 26 is the higher temperature, 19 can be the lower temperature. Maximum and minimum, what your meteorological report gives. So when we have looked at this total weather and meteorology, how is your weather affecting your aircraft? So you must always be aware. The most important thing what we tell our pilots is, you have to be aware of the weather conditions, local weather conditions, when you are going to create a flight mission. So unless the pilot is aware of what he is going to experience, he should not be taking off. So generally when we get up in the morning, what we do many times, the first thing in the morning is we come out and see how the weather is. So that means we can plan our day. Accordingly, a pilot should also plan the weather or plan his operations based on the weather. He must be aware of the operational limits that the manufacturer has set for his aircraft. All your manufacturers, as per the DGCA recommendation or the requirement, are supposed to give something called an operational envelope of the aircraft. That means in what operational conditions you can fly your aircraft. They will specify wind, they will specify what is the maximum altitude, they will not specify pressure because it is impossible to measure pressure for local people. So they will tell what altitude. So what altitude, what is the temperature, operating temperatures of your aircraft. They will give say 0 degrees or 5 degrees to 45 degrees. So you cannot fly your aircraft above that. And why they give this is because most of the sensors which we have put into our aircraft are actually designed to operate in a particular temperature range or a particular environmental condition. So you must not fly an aircraft if your aircraft is not built for the said operational environment. Always operate in the range that gives you a margin from the manufacturer. Manufacturer might tell 55 degrees centigrade. So we have to keep our own margin, maybe 45 degrees centigrade. Why we keep this? So for example, in case of temperature, the manufacturer tells you can operate up to 50 degrees centigrade. So the aircraft would have been tested in an ambient environment, whereas if we are flying in Rajasthan, where the air temperature is 55, my motor temperature goes far above the recommended temperature because of continuous friction and other things. So we always have to give ourselves a safe margin. And rain. Most of your aircraft, most of your unmanned aircraft, not manned aircraft, are not designed to be flown in rain. Most of it. But there are some aircraft which are, yes, can be flown in light rain. There are a number of things that get affected in rain. One is the moisture itself. The water which is there can damage your electronics. Correct? The second thing is your propellers can get unbalanced because of rain, because of deposition of moisture in the propeller. They can get damaged. And water ingress can again create problems with their electronics. Your batteries can short. So it is always better to avoid flying in rain for especially unmanned aircraft or a normal standard unmanned aircraft. Visibility. Government regulations stipulates that you can fly your aircraft only within a visual line of sight. So as the visibility reduces, the pilot's control on the aircraft also reduces. But there are a lot of questions. People ask, how do I determine visual line of sight? So for some people, it could be 1.5 kilometers. For a person like me with glasses, it could be substantially lesser. So you must understand until where you can maintain the visibility of aircraft, especially in conditions like fog. And if your the strobe lights, anti-collision lights are not working properly, you can lose visibility of the aircraft and you can lose control of the aircraft. So visibility is a very important factor while you are flying an aircraft. Ability to observe the aircraft also depends on the sun angle. So if you are flying directly towards the sun, those conditions, you cannot even see the aircraft. So you must always take into consideration that also. And then when there is a sunset, what we call as the dusk phase, so your visibility of the aircraft can reduce substantially. So all these things have to be considered. So also you can reposition yourself for the sun angle. Although you can also wear sunglasses. All these things the pilot must be able to take care. Apart from this, most of the pilots in unmanned aircraft use one application called as Windy. So you can go to Windy and you can also, this also tells you the same thing. What is the wind? Is there anything? What is the rain prediction? How much is the wind speed? All those things. So if you can look at this, that will also tell whether you can actually fly the aircraft or not fly the aircraft. It also tells what is the magnetic interference that you can expect on the day's flight. So magnetic interference again will affect your compass. So you can take a look at Windy application and determine. So it will tell there is a prediction also here. Then there is, you can see there is a wind gust prediction. So all those things you can consider using the Windy application. I think this is it from my end. If you have any questions, yeah, we can take it. Any questions on this? Yes. It is actually many things. So magnetic interference could be your local magnetic interference. Say for example, if you are operating very close to a high tension electric line, say 11 kilovolt line, those kind of things, the magnetic interference is high. But recently you would have observed that there was a geomagnetic storm which created the auroras in Mongolia. Even that affects your GPS performance. It also affects your compass performance. Yes, it is also a space weather phenomenon. It is also a local phenomenon. Any other questions? Yes. Yes, we do give pilot training in association with RPTOs. We also do separately. Yes. Okay. See, pilot training there are a number of categories of aircraft. You would have already gone through the sessions. So there is something called as a micro, small, medium, large. So in micro category and nano category, there is no requirement of a pilot license or a pilot certificate as stipulated by the DGCA if you are doing a non-commercial flight. But if you are doing a commercial flight, you still require a license. So there are RPTOs, something called as a remote pilot training organizations in the country. There are about 75 registered on the website. It is a Digital Sky website. You can find out who are the RPTOs. So what we do in RPTOs is basically all these modules that you have gone through, the similar module is actually taught for the incoming candidates, wherein we train them from the basics of aerodynamics to operation of a drone or a UAS. So for example, if a pilot wants to fly a quadcopter or a small category or a micro category aircraft, so we train him on that aircraft to fly. So this will go as it will be a close to about 10-day program, wherein about 4 to 5 days are used basically on training the pilots for the theory subjects, basically how aerodynamics work, all those things. Then another 2 to 3 days on the actual aircraft. The DGCA mandates that the pilot to be given a certificate be that he flies a simulator for 4 hours minimum. So 4 hours there will be a simulator training and then 4 hours of actual flight. So after 4 hours of simulator training and passing that examination, the candidate is taken onto the field to fly the aircraft. So it will include both simulator as well as aircraft training. That is the hands-on training. So this can be, you can take our number, we can facilitate, we can also provide this kind of a training. See, the cost varies between flying school to flying school. So it generally starts up to about 30,000, goes all the way in many cases up to about 65,000. So there. It was like we told Aerodrome report comes only in English. Sorry, I forgot to introduce sir. Sir is Wing Commander Somasundaram. He is an ex-Air Force person. And he is one of the first few in the country, or maybe probably the first in the country, to actually be trained in Israel for operation of high altitude drones.
speak for 5 minutes, you can please.
I can speak with that.
Thank you, sir. And finally, we are at the end of winding up of this national workshop. So now I request today's chief guest for valedictory function, Professor Godihal sir, please come on to the dais, and our CEO, Dr. A.M. Ramesh sir, and Dr. Anand sir, Senior Scientific Officer, my colleague Umesh Katki, Program Coordinator of this program. Please come on to the dais. I hope you have got some flavor of drones and drones technology. So we are coming to the end of the session. Now I request our Senior Scientific Officer, Dr. A. Anand sir, to welcome the guest and all of you for this valedictory function.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. This valedictory function is presided over by our beloved CEO Dr. A.M. Ramesh. I, on behalf of all the participants and on my personal behalf, I welcome you, sir. We have with us Dr. Jagdish H. Godihal, Professor and Deputy Dean, Academic Research, Presidency University, Bengaluru, as the chief guest of this function. Dr. Godihal obtained doctoral degree from IIT Bombay, obtained short-term course certification from IIT Bombay, IIT Madras, IIT Kharagpur, IIT Guwahati, IUCEE and Boston University, USA, in domain and engineering education. Successfully completed the course of IIT Kharagpur on integrated waste management for the smart city with an elite certification and NPTEL examination conducted by IIT Madras. He was recognized as the best teacher in 2004 by Gurujan Satkar Samiti, Aurangabad. Indian Society of Technical Education Award the ISTE MH24 chapter as the best ISTE chapter in 1995 when he was the secretary. Under his guidance, the project Urban River Restoration Case Study of Kham River, Aurangabad, won the first prize at DIPEX 2017, a yearly event of entrepreneurship development. He was the Chairman's Award for Outstanding Performance in Baja SAE India 2007, completion of competition held at Pithampur near Indore. He is the life member of Indian Water Works Association, life member of Indian Society of Technical Education, is life member of Indian Institute of Industrial Engineering, member of Institute of Engineers, life member of Indian Society of Agriculture Engineers, member Environmental Committee, Maharashtra Chamber of Commerce, Industry and Agriculture, member of Chamber of Marathwada Industries and Agriculture. With this big background, I welcome to this valedictory function. I welcome our resource expert, Dr. Chintamani Pai, Adjunct Faculty, Kumar Guru College of Technology, Coimbatore. Also, Mr. Vishnu and Mr. Kashyap, Space Geeks, Trilochana Aerospace and Defense Technologies Private Limited. Mr. Mugilan Thiru Ramaswamy, Skylark Drones, Bengaluru. Mr. Sri Harsha V, CEO and Wing Commandant S. Somasundaran, Unmanned Airborne Solution Private Limited. I welcome you to this valedictory function. I welcome Professor Balakrishna, retired professor of UAS, Bengaluru. I welcome all the dignitaries who are presented in this function. I also welcome all my colleagues and all those who are directly or indirectly involved in this program. I extend a warm welcome to print and visual media for this program. I welcome all the participants and those witnessing this program through social media platform for this valedictory function. Welcome and
Thank you, sir. Indeed, welcome you also for this program. Now I request today's chief guest, Professor Godiyal sir, commonly Jago, to address all of you.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳು. I hope many of you understand Kannada. Yeah? So I'll mix both Kannada and English. Okay, to some extent Hindi also. Okay? So, first of all, I congratulate and also thank KSTA. Always scoping with the time. They always come up with the topics to the society to train the people, especially young minds. I think Ramesh sir is very well synchronizing with the young minds. Always, whenever I discuss with him, no, today we are having a workshop on disaster or on drones. Yes, and when I entered and one of the speaker was mentioning, see, already there are many revolutions have happened. Okay, and revolutions are going to happen. Okay, so likewise we have come up with mobile as one of the revolution. Then comes internet as one of the revolution. Now we are having IoT as one of the revolution. As is rightly mentioned, now drone will be another revolution in the future. That is, I can say, even in the industry 4.0 we talk about that. Now industry 5.0 is coming. So ultimately when industry 5.0 is coming, along with that this drone. Now drone will be like whenever you are carrying mobile. In future also, after 5-10 years, people is going to carry a small drone. Whenever they want to collect some data, they will just have a flight of that, and then like in the mobile only, they can do that. Those days are not far away. For that, I congratulate the KST and Ramesh sir for making you aware about the drones. And also, I thank both the KSTA and the CEO for providing opportunity to us as a Presidency University to showcase you our capability and competency in the drone. We have our own drone, and we are doing some consultancy also in land use planning and all those things what we did. The same, I think you have yesterday, all of you have visited our campus and you have undergone the real demonstration of how the flight planning is done and how to acquire the data, what data need to collect, what is the camera, drone cameras, and what is the radar, and everything you have been aware about that. I hope this workshop has provided few insights. This is only, as some of the speakers might have told you, that it is only a journey you have started now. The journey you have started, now the destination, you decide the destination. Whether when you when you step into the bus for a journey, whether you want to get down at the next destination or you want to carry forward as you move up the ladder. As one of the speakers rightly pointed out, there is IIT Mandi. They are providing that opportunity. How many of you are going to encash that? Like that it is only provide you the insights. Such workshops definitely provide you the insights, how you can take it, how far you are going to take it, and then it is only a learning. You have learned something now. Now after learning, now you need to apply that in your own field. Then definitely this drone technology is going to help. One thing how many of you believe that drone is going to provide you everything? Is going to provide you everything? And then actually drone is a vehicle. In my opinion, drone is a vehicle. Okay? Then drone is just like I want to go to Mysore. I got Maruti also, I got BMW also, I got some racer car also. Both, everything is there. But now, which one I have to use and then how I have to use? So that is, I require a driver. In the sense, I am expert in that. Okay, then in addition to that, I require some accessories also. Okay, drone is going to take, that is why you require sensors, what type of sensors. So actually, what you are going to do with the drone, you are going to collect the data. How to collect the data, what type of data you need to collect, that means what type of sensors are required, what is the flight height and how you are going to fix, what is the area how you are going to cover. What is the resolution of that? That you might have, I think you might have got some insights about that. But see, how many of you learn mathematics by reading? How many of you learn engineering drawing by reading? To a certain extent only. But if you want to become master in that, you need to practice. Likewise, drone also. So that means every day, not every day, at least whatever you have learned theoretically, you need to put into practice. So that when you are going to do, that is some demo or some real case studies you need to take. Whenever is possible, you try to apply. Then how are you going to validate whatever you have got from the drone is correct or not? That is, validation is also required, means, isn't it? So generally in our engineering colleges, we go for a survey, a traditional conventional survey. Okay, it's a leveling or a theodolite survey or a plane table survey. Now they are all almost, they are all gone, but the basics we need to teach them. Based on that only, I am going to get this thing. That means once the new technology is coming, I cannot go away with the old one, old things. They are all the basic concepts. So that is why first and foremost things that the course itself is now basics and real world applications. Okay. So now I can utilize the drone for many purposes in any area. That's why I say it is a Revolution 5 or something. Even I can go to that extent. But what knowledge we require, how we have to acquire that knowledge. Okay. I think you might have learned also, you cannot fly the drone wherever you want to like. You need some lesson, permission to be sought, isn't it? So then especially if you are nearer to the airport, definitely you need a special permission and you have to state the purpose and all those things. So in addition to that, how many of you really appreciate that definitely drone is going to provide an impetus to the development of the nation? How many of you believe in that? Definitely. First thing is it's going to save a time. Second thing is it's going to collect a very precise data provided if you are expert in that. Okay. If you are expert in that. Okay. And then third one is there are so many softwares are available. You are not going to get, you need to interpret the data once you collect it, whether it's images and everything. As per your requirement, many softwares are available. How those softwares, you will be expert in that. Okay. So whatever you get, you can extract the information to your need, and then the inferences you are going to draw from that. That is another skill you need to study. Okay. So one is, the basic thing is how to get with the drone the required data. Then planning for the collection of the data. Then once you collect it, then you are going to have a processing of that data. Processing, drone cannot do the processing. You have to take, then you have to do it in a softwares. Okay. Again, do you have a high-end computing facility? Because more images, complex the image means ultimately you require very high resolution, high-end computing facility. Depends upon the accuracy level you decide. So all these things, definitely you are very fortunate. And then definitely you people are young generation, you are already born with the golden spoon in your mouth. Not like us. We are born without any spoons, isn't it? At least now you are having everything at your disposal, but only thing is, that is another thing will make you lazy. Okay, when we are doing PhD, we used to write, we have to go to library and then we have to refer the hard copy of the journals, we have to make a note and then we have to review the literature. Now, sitting at your fingerstep, within a fraction of a second, you get hundreds of papers and definitely you can process it and next day you will come up with a review. So that is why, that makes sometimes you lazy. You will do it. Because you say that it is in a fraction of a time I can do it. You can say like that. But the person who is very intent and who is doing want to reach particular level, definitely you will take the encash that. It is a question of encashing. Are you going to encash that facility is available in the right time? That is one thing. So with this, I want to give some tips to you people, how you can see, I'm not that expert like Dr. APJ or Vishwesvaraya to give tips, but whatever I have acclimatized or whatever I accustomed to in my career. So if you want to be a successful in any future careers, so first of all you must have 4 eyes. Okay, that is eye is eye, that is eye, don't go with that eye. Okay, in the working, eye is not going to be important, it's we is going to be important. But eyes in the sense, you must have, first is insights. Whatever you do, you must have an insight. Once you have an insight, then involve in that, involvement. Okay, then once you have involvement, then you should have an integrity. Okay, integrity comes with you only. Integrity will not come by policing, somebody is policing, I am doing. No, it is integrity. Then ultimately inspire. Because we are all human beings, okay? Then definitely we get fatigue. After certain times, we get fatigue and somebody will come and motivate. But you cannot expect every day someone will come and motivate you. Instead of that, you inspire yourself. Okay, if you inspire yourself, then ultimately you can achieve whatever you want. Okay, it's just like your drone. Okay, what height you are going to go and what resolutions you are going to have and what data you are going to capture, that is there in the life. So with this, I think time is enough. I think I'm going to stop over here. I don't want to get you bored because you are in the new technology. Okay, so if you have got any specific questions to ask to me, to the best of my knowledge, I'm able to answer that. If you do have any specific questions. Do you have any specific questions to ask? Then, on all the 3 days you have studied, you have interacted with the best of best experts. I thank them for providing you the knowledge in a best possible manner. So, do you have any particular questions regarding not only on drone, anything? Yes, sir, bullying. No, sir, that in that only 2 aspects is there. So, cut and paste and get the PhD, what you are telling. It depends upon basically the supervisor. First responsibility is supervisor. Okay, second responsibility is student. Third responsibility is institute. Fourth responsibility is society. Okay, this is what my thinking. So if I am a supervisor, okay, so then ultimately I have to see to it that how my student is going to get a knowledge from that particular PhD and how particularly he is going to do the PhD. Okay. So that's what I answered your question. Okay. Yeah. Do you have any other? Yeah, sir. Yeah. That first thing is, up till now, basically we are service-oriented country. Okay, we were never in the manufacturing hub. Now slowly after the COVID, now we are becoming manufacturing in every aspect. Even we are also started manufacturing drones also at a smaller scale. But in days to come, definitely we are going to become. And already it has been initiated. Okay, now for example, you can take now HAL. I think many of you following HAL, where it was now, where it is now. That is indigenous, that means first and foremost is mental block. When I am in India, I never do anything, but when I went to America, I am the main person, whatever the new things comes there. But when I am in India, I will never do anything. So that is one thing is there. See, we are 150 billion. Okay. So they are only 32 crores. Okay, then lot of resources are there. We have got a resources crunch, but those days have gone. We are going to come up. No, don't worry. That means we are going to become in near future one of the best drone manufacturing hub. Thank you. Okay. Okay. Yeah.
50 PLIs have been already issued.
Yeah.
50 companies have been given PLI. PLI, product linked
incentives. Okay.
So there are 50 drone companies which have got PLIs. So they're
Yeah.
already working on it, they're already paying them. Okay, so in PLIs, 50% of whatever is the money being put by the company is reimbursed by the government. So government is doing all its best. There's only some amount of step we need to take. So that's going to happen.
Definitely.
The government has already clearly mentioned 2030 India should be the global drone hub.
No, another thing is, sir, that means now in the digital payment, who is at the first? And then who has started that? And that definitely you may say in some way COVID may be a disguise in bless or whatever you say. COVID has come and then we have become so much advanced in digital payment and everything, even online classes, effective online classes, so many in education and everything. Okay. I hope I answered your inquiry. Any other person, sir? Do you have time or 1, 2 or 3 minutes? Okay. Then okay. Okay. No, I think, no, I wanted to end I don't want to come in your feedback, in between your feedback and KSTA. That's why I wanted to end whatever the thoughts I wanted to say, I have said this way. And anybody is having any particular questions, you have a last chance to ask. Okay? Our university is fantastic university, doing all the way around. What else? What else you want to tell me? Huh? See, we have started in 2015, and now we are having almost 15,000 students at the campus in 68, very vibrant campus you have seen, and very green campus, very lovely campus, and we are always 15,000 young minds are surrounding me. That's why day by day I am becoming young, even though I am 60. That is what actually I can say about, and then we have got a very tremendous scope also. We have got the facilities and everything available at our. When Ramesh sir asked me, are you able to provide drone? At once I say, without taking anybody's permission. Okay, we are going to provide drone, everything. Okay, that is about my university. I am happy with my university facilities. Yeah. Okay. Thank you for listening to me and providing me the support. Thank you, sir. Thank you.
Thank you, Jago sir, your inspiring words. So he really inspired all of us, telling a lot of things about drones in a very short time. And now is the time for feedback. How you are really going to feel about this 3 days workshop? Voluntarily, please come and tell your feedbacks about this workshop. So please come voluntarily. Yeah, please. And tell your name and your company and please.
Hello all, my name is Pradeep and we are a startup of to aerospace and defense sector, and that's my introduction. And thank you. First of all, I would like to thank the honorary guest and KSTA to organize such a wonderful program. I believe we had brainstorming sessions and a lot of knowledge that we gained throughout the last 3 days. Thank you for the supporting staff as well for arranging. Without it's all flawless, went very, very well. And one request I would like to make to the organizers is, why don't we scale up now? Why don't we go into advanced training? I think that's the ask of the day, or ask of the upcoming generation. And hopefully we would like to see all of you and more of you in the next advanced training, if it is an opportunity for us to grow more. Yeah, and I would like to thank you again for giving us the opportunity. Thank you, sir.
Thank you, Pradeep, for your feedback. In fact, our Ramesh sir, we were discussing with the Omkar sir about this advanced training program. But this is not free, we will really charge for that. So certainly we will do that program. Academy is always giving impetus to recharge all of you. I definitely will do that. So any other person, please?
Very good evening. My name is Satish Rajan and I'm a faculty and I'm also associated with BPAC, Bangalore Political Action Committee. So, the first time I saw a drone was somewhere 1 year back in an event. So I was very curious to know about the drones. And KSTA is like my second home. Whenever I want to learn something interesting, KSTA provides me that opportunity. Thank you, Ramesh sir. And last 15 to 20 hours have been very enriching in the last 3 days. I really loved each and every session. Whenever we want to use something, we have a catalog or a prospectus which we refer to know the applicability and how to use that. So basically, when you are using something where the cost is very high, stakes are very high, it is recommended to have something like a training program to know everything about the product. So since the drone is an equipment involving lakhs of rupees and having lots of complications, it's indeed a privilege to have something like a training session like this, and all the 15 sessions were enriching. And also the practical session at Presidency University was also really nice, very exhaustive. All professors, head of institutes, CEOs, professors and scientists providing at a very affordable charge, free of cost for us, and enriching more than 80 students here. And the food arrangements were also so good. And interacting with so many students was also very nice. Nothing I can ask for more, covering from rules, the principles, the applicability of various guidelines, procedures, the weather conditions, the basics of drone utilization, so many things within 18 hours. It's really amazing. Okay, so thanks for that. And thank you, Professor Sir. Thank you, Head of the Institute. Thank you, all the respected delegates. Thank you, all my friends. We had very good interactions in between the break sessions. We had very good humorous sessions. So I can't ask anything for more. Thank you so much.
Thank you, sir, for your valid inputs. Please, anybody? Yeah.
A very good afternoon to one and all present here. I am Divija Sharma. I am a second-year student from Christ University Yeshwanthpur campus. I am truly honored to stand before you today and express my gratitude for the incredible opportunity I had to volunteer at the 3-day national workshop on UAVs and drones organized by the Karnataka Science and Technology Academy. As a second-year student, this experience has been invaluable in shaping my understanding of real-world applications in the field. Being entrusted with the responsibility of handling the technical aspects of the event, from live streaming to controlling the media encoder, operating the video camera, and managing the editing process has been a profound learning journey for us. It allowed us to apply theoretical knowledge in a practical setting, enhancing our skills and giving us a glimpse into the professional world we aspire to be a part of. I would like to thank Anthony sir for his guidance and constant support. Thank you once again for this enriching opportunity, and I look forward to applying the insights gained during this workshop in my future endeavors. Thank you.
Thank you very much for your valid feedback and also providing your service voluntarily to live streaming our sessions. Anybody? Please.
ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. Good evening to one and all. This 3 days national workshop on basics and real world application of UAVs was absolutely very informative, and it's impacted for students and aspiring entrepreneurs like us, and the live sessions which was held at Presidency College was something unique with operation of the drone and the CD fly software, and I would like to thank Jagdish sir for being so humble and inspiring the students and us. The resource key persons are definitely very delivered their sessions timely, and they given the lot of information and well as the practical knowledge where should implement these applications about the drones, the upcoming in nearby future. As our dignitaries said that there is nearly 1 lakh pilot is definitely needed to build Atmanirbhar Bharat. So I strongly believe that in few more steps or few more years we will be a developed nation. Thank you. Let us build our nation. Jai Hind, Jai Karnataka. I'm sorry to introduce myself. This is Ashok Kumar. I studied in BIT, that's Bangalore Institute of Technology, Vivipuram. Currently I'm running a startup called S4 Networks, which is into networks and cyber security. So that is my domain expertise. Thank you, sir. Thank you for each and every dignitaries who have organized, and thankfully for the Karnataka State Technology Academy.
Thank you, Shukumarji, for your valid inputs. So, in another two or three, Mike. Anybody else? Okay, thank you all of you. Now I request the main man behind this workshop, our source of inspiration, the guider, the driver of this program, our CEO, Dr. M. Ramesh sir, to give presidential remarks. Pilot, yeah.
Good evening, everybody. Very good. I'm getting voice from front, not from back. Respected Dr. Jagdish Godiyal sir, Mr. Pai, Dr. Pai, Mr. Sriharsha, Dr. Balkrishna sir, and all the delegates, Dr. Anand, Dr. Umesh, Dr. Srinivas, Shantraj, Madhayagoda, and Dilip Kumar, and all my colleagues. I hope this 3 days training program was quite useful. In fact, I was not myself aware of how to conduct a training program in drone technology. Then I spoke to our mentor, Dr. Onegoda sir, as to how to conduct this training program. He gave the syllabus, 3 days or 4 days syllabus that has been prescribed by DGCA, and gave few names as resource experts. And it's, in fact, Multiplex drone company was supposed to help us in all respect, but unfortunately they have got a big project in Uttar Pradesh. In fact, Vanegowda sir told that if somebody is interested to go to Uttar Pradesh and work for 2 months, they will be giving TA and also accommodation, food and accommodation they will be giving, but there is no stipend. If some youngsters are interested, they can go there. They will get you the pilot license also after completing 2 months of training. As the wing commander told in the beginning, Mandi, IIT, like similarly they will also give a training for 2 months. That too in the field. You have to be there in the field, not only in Lucknow, in different parts of Uttar Pradesh, wherever they assign. If somebody is interested, you can give the names. We will be sending the names to the multiplex drone company. Most probably agriculture. Agriculture. If youngsters are interested, they can give their names. Well, then sir gave me DGCA syllabus. So in 3 days, how to conduct all 15 or 16 talks. I put everything. I got some 15 experts. In fact, I never wanted to leave even a single topic untouched. So when somebody was not able to come regarding risk management, I requested Dr. Pai to touch upon risk management also. Thanks for accepting our invitation and delivering a talk on risk management as well. And this 3 days training program is only an orientation program. In 3 days you can't learn everything, you can't implement everything. And when practical experiential learning was concerned, we didn't have a drone ourselves. Then I requested Jagdish sir, immediately he gave green signal, and yesterday he went there and experienced how a drone flies, how it is operated. Well, in the coming days, we plan to have a 5 days training program wherein we will be having 2 days theory and 3 days practicals. Either we'll tie up with presidency or you have a training facility with you? Yeah, we may tie up with them, we'll have discussion and plan. For this program, we got generous funding support from SCRB. Of course, we have not got the money yet. From KSTR, we have spent for this. We hope they will be transferring the money soon. For the next program, we won't be able to conduct, as Srinivas told, without fee. The nominal fee will be charged, and from academy also we will be putting some amount. And most probably we will plan in February. We will be planning a 5-day program in February, tying up with good startups and university like presidency, and plan a good program. Of course, all resource experts were really good. I have gone through their CVs, and Mugilan was very helpful for me. He suggested Mr. Sri Harsha for a talk on weather and meteorology. That was also a topic that I did not get right person. Then I called Mugilan. Immediately suggested Mr. Sri Harsha. In fact, in future programs, we will be depending more on you and Mugilan. We want industry perspective rather than just academics. They have a startup and they know how a startup works. We want such an experience. In fact, our Onkar sir is also a very good expert. In morning, I also discussed with him regarding conducting a 5-day training program. That will be of much use. In fact, most probably we may be able to take a license with DGCA if we conduct 5 days program. Procedures and all will depend on you to help us. And we got, as the Ashok Kumar and Pradeep and others told, this training program probably would be very useful for you. You have a lot of take-home message. You could broaden the horizon of your knowledge a little bit on drones and UAVs. In the future training, certainly you will become a good expert in drone. Only for becoming, I don't think only becoming a pilot is enough. As Onkar sir told, internship is also a possibility. You please contact Dr. Onkar, or you contact us if some student wants to pursue a career in research in the field of drone, we'll certainly contact Dr. Omkar sir and help you in that also. So our 3-4 youngsters from Christ University, volunteers, were very friendly and had come to picturize the proceedings of this 3-day program, and also they have prepared a proceedings also. I have not gone through it, but certainly it will be good, I hope. Thanks to Christ University and all of you for being with us for the last 3 days. With this, I once again thank all of you for being one of the best delegates, because you have been very interactive. In some of the training programs we see people just sit, they don't ask questions, they go with lot of not take home message, lot of questions back home. But you have cleared all your doubts. I am sure all the experts were able to deliver what you expected. In future also KSTA organizes programs like this with excellent resource experts. It is it is the culture of academy which has come from Professor U.R. Rao, former chairman of ISRO, followed by that Dr. S.K. Shukumar. I am sure all of you have seen Belladu antenna. He is the architect, and followed by that Dr. S. Ayyappan, who was the DG of ICR, Director General of ICR, and our mentor Dr. Onnegoda sir. We have been with Dr. Onnegoda sir for the last 20 years. He has been a guiding force for us, and in fact this training program was because of his, his encouragement. In fact, I was not aware of how to conduct this. He only encouraged me to conduct this program. On behalf of all of you, I must thank Dr. Onnegoda sir for this good program. I also thank Dr. Pai, who has, in a very short notice, in fact, he struggled to get reservation in the train. In spite of that, Dr. Pai and 2 of his associates have come from Maharashtra to be with us. Thanks, Dr. Pai. Vishnu? Mr. Vishnu and Mr. Kashyap. I am nearing 60 now, I forget names, so excuse me. So I also thank Sri Harsha and Wing Commander for being with us, and all the resource experts for delivering excellent talks. Thank you very much.
Thank you very much, sir, for your kind words. Now we are going to run a short 1-minute video prepared by our Lobo and the team. Please, Lobo, can you play now? request you to include this valedictory session also. Lobo, excellent work. Thank you very much for you and your team. Please once again give a big round of applause. So thank you very much. And now is the time to propose vote of thanks to all of those who have contributed a lot to organize this workshop. I request my colleague, Mr. Rupesh Katiki, to propose vote of thanks.
ಎಲ್ಲರಿಗೂ ಶುಭ ಸಂಜೆ. Very good evening to one and all. I won't take too much of time. Already everyone knows the contribution of resource experts and KSTA and CO and staff and all your presence. Dignitaries on the dais, off the dais, my dear colleagues and my dear fellow participants. I would like to express a formal gratitude to one and all who are the reason behind this successful event, a 3 days national workshop funded by Department of Science and Technology, Government of India, Science and Engineering Research Board. First and foremost, I would like to thank our CEO, Dr. M. Ramesh sir, and who is the president of this valedictory function, on behalf of KST and on behalf of all of us. Thank you very much, sir. Just for the namesake, I am a coordinator, but he is the one who has taken all the responsibilities and he is the one who has given his shoulders. Thank you very much, sir. Also, I would like to thank Dr. Jagdish Kodiyal sir, Professor and Deputy Dean, Academic Research, Presidency University, Bangalore, not only for his presence and supporting in Presidency University for the demonstration of drones for our participants. Also, I would like to thank all the technical speakers, Dr. H. Honegowda sir, Dr. Chintamani Pai, Mr. Bhivan Pasumatre, Mr. Nagur Kani, Mr. Karthik MH, Dr. Uday Shankar Puranik sir, Dr. R. Hebbar, and Dr. S.N. Omkar, Shri Neeraj Ram Prasad, and Shri Mugilan Thiru Ramaswamy, as well as Mr. Shri Harshavi and Wing Commander S.M. Sundaram sir for being part of this 3 days national workshop. Thank you very much for accepting our invitation and throwing light and sharing your inputs and knowledge with all the fellow participants. Thank you very much on behalf of KSTA, on behalf of all of us and my own behalf. Thank you very much. Also, I would like to thank Swidal, Divija, Divya, Dalij, who are from the Christ University for their support in this 3 days workshop. Apart from them, I would like to thank Department of Media Studies, Dr. Nirmala and Dr. Anto for their valuable support in this 3 days workshop. Last but not least, I would like to thank all the staff, technical team, non-technical team, who are the fingers. If KST is a feast, without my staff, who are the fingers of this program, I can say if the challenges are faced by a feast, ಮುಷ್ಟಿಯಲ್ಲಿ 5 ಬೆರಳುಗಳಿದ್ದಂಗೆ ನನ್ನ ಅಕಾಡೆಮಿಯ ಸ್ಟಾಫ್ ಅಂದರೆ ಆ ಥರ. ಟು ಒನ್ ಆ್ಯಂಡ್ ಆಲ್ ಐ ವುಡ್ ಲೈಕ್ ಟು ಹಾರ್ಟ್ಲಿ ಥ್ಯಾಂಕ್ ದೆಮ್ ಆನ್ ಬಿಹಾಫ್ ಆಫ್ ಆಲ್ ಆಫ್ ಅಸ್. Last but not least, I would like to thank all the fellow participants who have participated from various districts, not only districts but from the states, from Mumbai and Vellore, Tamil Nadu and other places, for their presence, valuable presence here. And thank you one and all who are the reason behind this successful workshop. Also media people and who are witnessing this program in live and social media, through social media channels. Thanks to all of them. Thank you one and all.
I should especially thank Presidency University for giving us the facility to have field experience. Thank you.
Indeed, thank you very much, Umesh Katke. You did actually, for all the 3 days. I meticulously planned before 1 month. Now, before going to that, once again, please big round of applause to Umesh Katke. It took a lot of pain conducting this program. And ಇದು ಮಂಗೈಯಲ್ಲಿ ಮುಷ್ಟಿ ಅಂತ ಹೇಳಿದ್ರು 5 ಬೆರಳು, but because of the leadership quality of Honegowda sir and Ramesh sir, we are all working from scratch to this level. Really, from organizing this kind of workshop, lot of pain we took all, from buying the stationaries pads and everything, making these groceries and food and everything. We all take a lot of care for making this program successful with the leadership of Ramesh sir and that kind of activities we are doing. Before that, I request all the dignitaries and all of you to please rise up for the national anthem. Thank you, Ananda. Wish you all the best, all of you. And before that, we have a group photo, and then we can go for IT, and you can collect after group photo. Please collect your certificates in the reception counter. Thank you, Ananda, and happy and safe journey to your home. Feedback, please give it in the reception counter.